Well, we're live, and I practiced this a bit yesterday with the live stream. Went pretty well. Started off a bit weird. Didn't know what I was doing. I still don't know what I'm doing. So everyone who is watching online, who is a few people, I know there's a few people watching. I think there's a few people watching. I don't know. We'll see. Please do talk in the chat if you have anything to say. I'm not going to be able to see it if it's in individual chats like outside of Twitch or YouTube. I might see you on the Discord. There's also my internal chat running in WebEx, which I'm not looking at the moment. Maybe I will in a bit. Maybe I will. Maybe I won't. Anyway, today we're starting a week and a half of a hackathon, and in this run, we're going to be building something from scratch. We're going to be starting from zero. Well, not zero. I've done a bit of thinking on it, and I've done a little bit of prep work in thinking through some of the challenges. But it's based on a real challenge, something that actually exists today. Something that actually was brought to me by one of my colleagues. His name is, actually I won't mention his name. Maybe I will. The person knows who they are. If they're listening. Let me know if you're okay for me to mention your name. Anyway. Very smart person, came to me and said, you know, we've got a real problem, and we can't really diagnose what's happening when a customer has a problem when they're using our product. And in particular, the product I'm talking about right now is called Enterprise Security. Enterprise Security is a wonderful application. It's actually one of our main products in Splunk Security, and it's a SIM basically. It's Security Information Event Management tool. And if you don't know what that is, don't worry about it. It's not important because that's got nothing to do with the tool that we're building today. But the crux of the problem is that the tool is, or the product is complicated. It's got a complicated web interface. It's making a bunch of back-end calls. And we're trying to figure out performance problems where things are getting stuck, where weirdness is happening, slowdowns, and it's really, really, really hard to diagnose this outside, you know, being in front of the customer, watching them do this. Because we can't recreate those environments. You know, that every environment is different, every configuration is different. There's just no way to determine where the problems are, right? Well, I mean, we obviously can tell them where they are, but we can't replicate the experience that the customer is having. This is really the problem, is the experience the customer is having. I'm just responding to somebody here in the Discord. Yes, I am. I'm live now, live right now if you're interested. Live on YouTube and live on Twitch, making a fool of myself. Or trying not to, but probably am. Anyway, back to the problem. So, really, when you think about it, like you're a customer and you're using this web interface, and you're like clicking, and it's just not responding, or it's slowing down, or it's like you're dragging stuff and it's not responding, or the drag bars are rendering really poorly. You run a search, which is the core of Splunk. It runs on search because it's a giant search engine. If you didn't know that, but the problem that is these searches take different amounts of time. They can time out, and our UI may respond differently. It may give the wrong message. It may get things out of sequence. It may get things unordered. So, how do we solve this? How do we fix this? How do we recreate what the customer is seeing without like taking a clone of their environment? How do we see what they saw and go back in time and visit that? How do we do that? It's a challenge, and I've been thinking about it for a bit. And there's always been a solution. Well, there's not really a solution. There's always an ingredient of a solution, and that ingredient, the ingredient is a HAR file. If you don't know what a HAR file, it stands for HAR. It stands for HTTP archive. And what it is it's a conversation of everything that has happened between a front end and a back end, a client and a server, whatever, however you want to phrase this stuff. So it's it's a full breakdown of exactly what happened, when it happened, what was sent, what wasn't sent. The only thing it doesn't contain is cookies, particularly secure cookies, because that just violates the whole point of a secure cookie. So there's a few challenges there, but it will give you, a representation of exactly what happened in the order that it happened. So you've got that entire conversation recorded. Now that's great, but it's basically just a collection of requests and responses with bodies and headers and okay, good. When you've got millions of them, it's really hard to figure out, well, which one was slow, which one was messed up. Sure, we can start to search it, but that works fine with little teeny little HAR files that we use for demo purposes or trying to understand how something works, or understanding the schematic of a HAR file. But when you actually get a HAR file, a real HAR file, hey, if anyone's in actually listening to me in the room, wave your hands. I don't see anyone waving their hands. I don't think anyone's listening to me. Maybe no one's listening. Maybe no one's watching, or at least no one's in the office is watching. Maybe. We'll see. I'm going to ask a question. Is anyone watching? No one seems to be watching. We'll bring that up. Okay, anyway, let's get back to it. Oh, I see somebody typing. Oh, there we go. In yet. Yes. Thank you for watching. I appreciate it. I can't see, like, I don't have any of those statistics up because it's going to distract me. So I'm just trying to focus on what I'm talking about here. Anyway, back to this problem. Well, the HAR file is massive, and we're talking gigs and gigs and gigs. Gigs and gigs and gigs and gigs. And you can't load those files up sometimes. You're talking maybe a 60, 70 gigabyte file. Unless you've got 60 or 70 gig of free RAM, not going to work. And most tools out there won't be able to read that, so you need to take a different approach to reading this stuff. Well, how are you going to search a 70 gigabyte file? Not that they are 70 gigabytes, that's a little extreme, but in tests for sure, they can run up into the 10s, 20 gig range pretty easily. But let's just say 5 gig for now, even 5 gig. Have you ever tried loading a 5 gig file into a tool like VS Code? No. Doesn't work. Oh, hello. Yes, Dreams API. I recognize you. Thank you for watching. I really appreciate it. So, back to the conversation. The main crux of the problem is trying to search, trying to look through, trying to figure out where a problem is in a HAR file, and then figure out which request at which point, which component, because there could be 10,000 of the same things. How do you know which one was wrong? How do you know which one is slowed down? There's just no way to make sense of these requests and responses in the first place, because it's just a stream of them, and then there's no way to see them kind of against the UI. So what I'm going to be doing is building a tool that is going to read in or stream in HAR files. I haven't quite figured out the right way to do that yet. We'll get there soon. We'll figure that. We'll start the design process soon. And then it's going to read in the HAR file, and then it's going to render it out. So a little bit, if you ever use Vacuum, you've got a nice dashboard, terminal UI. There's 7 viewers on YouTube. Hey, 7 people. They could all be my friends though. I don't know. We'll see. I see some people. Great people on YouTube. Hello everyone on YouTube. Hope it's not too boring so far, because I'm still practicing at this. I'm still learning, trying to build some new muscle memory. And I'm going to be building this application. So if you have back to the terminal application, have you ever seen Vacuum? Have you ever used it? It's actually part of all our pipelines at Splunk, so you've probably heard the name at least. You may have seen it working, you may have seen it running, maybe not. But anyway, it comes with a terminal UI via the dashboard command. And that is built in a framework called BubbleTea by Charm, which is amazing. It's the pinnacle of Go-based terminal UI frameworks out there. I've tried them all, or I've tried a lot of them, and this is the best. It's beautiful. It's actually based off the same Elm architecture, so it's a solid design in terms of its life cycle. Some people might get a bit, might not like the way it handles everything as strings mostly, but anyway. I digress. The library is fantastic. I used that to kind of revamp the entire UI of Vacuum. I did that about 2 months ago, and went through the learning process of what it takes to understand how the framework works and how to use it, and taking the existing code and basically chucking it in the garbage and starting again. So the challenge today is, first of all, how do we read in massive files efficiently? And the only way to do that is streaming, right? Streaming paging. You can't load it all in once. The paradigm doesn't work. So we're going to build a mechanism to stream this stuff in and page through it. And all the other things we're going to need to do to be able to navigate and do lookups with efficient, big O operations on there, ideally O1 for lookups, because it should be. I don't see why it could be any deeper than that. Anyway, maybe not. We'll figure it out. We'll get there. Well, that's the fun part comes in. So first of all, we're going to parse it, then we're going to render it and have a navigation so you can scroll up and down and look through all these requests and responses and actually see them. You can see the payload, JSON, so it'll be colorized and rendered out nicely. So it's, I can actually see this instead of it being just this, escaped blob inside quotes in a JSON file, which is just it. You can't make sense of it. So it's all of that. It's how you can actually render out the payloads in a meaningful way. You can see headers, you can see the parameters. As much as we can render, we'll render. And a way to kind of scroll through it, page through it, scratch through it, whatever term you want to use. So we'll be able to go kind of, that's the first thing we're going to be building as part of this tool. The second part is going to be like a replay server. So a little bit like Wiretap. Again, Wiretap is another tool that I've built that can be used for testing. We don't use it for everywhere, but it's actually part of some of our internal tooling at Splunk, is on part of our Pringle toolkit. Actually, it's called the Pringle Dev Server. I'm not going to talk about Pringle, that's something else. But what I am talking about is Wiretap, the foundational piece. It's similar to that in the fact that it's going to listen to traffic, send back mocks, but instead of mocks, it's going to be the actual responses that are kept in the har file, and that's going to give us the ability to replay the conversation. So every request coming in from the browser, we're going to match with the closest first one in the har and send that response, and so on and so forth. So everything should come in. Now there's some edge cases, there's some unknowns. Worrying about state may be a problem. It may be not. I don't know yet. I know there's always gotchas in those when you're dealing with trying to make sure that we need to inject this header, and this cookie was available and it's not, and it's used by this and that, and this path is different, and we're proxying that, and blah 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 blah, and the paths don't match. There's always a million things that need to be configured and changed. That's why there's so many configuration options in Wiretap. But I don't know. We'll figure that out as we get there. So that's the premise. Is going to be a server to replay, and also I forgot the last one of the major feature. The major feature of the replay server is not just to replay it, but it's to be able to set breakpoints. So as part of that terminal user interface, you'll be able to set a breakpoint on a request or a response. I don't know. We'll figure out which one makes more sense when we get there. We'll be able to say, as it's coming through, stop there, stop and wait, and pause everything. So I want to go and inspect the front end or the client, whatever is sending the request, and then I want to do a profile on that or run a debugger on that and see what's going on and how it's gone into this state, because it's here that things went wrong, or at least it seems to be. This is where things went wrong. So in theory, if the ability to be able to see the conversation from the point of view from the server, to pause the conversation from the point of view of the server, and then have the client, sit there and wait, and then have the server act like it's the real deal, responding with everything that was sent back, and we can hopefully recapture that same problem that we saw with the customer, and we can see what they saw, we can experience what they experienced, and we're going to end up with a really great tool. And this applies to any use case. This doesn't apply just to our particular implementation inside Splunk. It's actually for anyone. Any company has this problem. Any developer has this problem. It's like, I'm on call. I've got a diagnostics issue. I need to figure out what happened, and the customer collects the har file. Then what? At that point, you can spin up this tool and you're off to the races. And it's actually inspired by one of my proteges, I would say. He's going to get a big head now when he's heard me say that. But he's a very smart gentleman, and he had this problem. He's like, I'm trying to figure this out and I can't solve it, because he was on call, and I thought, well, wouldn't it be great? He said, yeah, that would be great. So I actually used him as my kind of, I'm the PM and he's my customer. And I asked a bunch of questions. Well, what do you want to be able to do here? How do you want this to be able to work? What would you want to expect to see? What would you expect the behavior to be on this? How do you want to use a tool like this to diagnose it? So I went through all this requirements capturing already. I've already done, I think the most important part of software engineering is really, really, really good requirements capturing. Really understanding what it is we're building here and why we're building it, not just here's a ticket and it needs a feature, go build it. Okay, blah, 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 done. Why? I think it's something that gets overlooked a lot of the time, is slowing down at the beginning, really slowing down at the beginning, and not going off and building elaborate architectures and diagrams. They need to evolve more organically as you find out more and ask more questions. So my point of view is, or my personal way of working, or the way I like to work, you can't always work this way, it's ask a lot of questions and ask the dumb questions. Ask the questions that are obvious, because everyone's thinking, well, that's obvious, or is it? But I can't ask it because I'll seem really dumb if I ask that obvious question. And you'd be surprised just how many times people go, yeah, you're right. Why are we doing that? Or why is it that way? Or why is that thing there? And, it's like, okay, sure. Yeah, we didn't think about that, or we thought, we just assumed. Oh, I just assumed. Okay. Assumption is the mother of all screw-ups. All screw-ups. Fubar is where assumption was born. I'm not sure what that term means. I'm not going to say it out loud, but you should go look it up. So, good requirements. So I know exactly what this tool needs to do. It is very simple. It's super simple. It does two things. Well, three things. Three things. You can visually explore a half file. Look, I've written it out here. Let me actually, I'll kind of bring up my terminal here. Wait, where is my terminal? There it is. Is that the right one? Yeah, it is. Yeah, I need to rename it in my stream tool. I've still got the wrong name in there. I was like, hang on a minute, that's not what it's called. So these 3 points here, I'm not sure if you can see it. I'll kind of get out of the way. You know what? I'm just going to make myself small. So I'll get myself out of the way. All right. Okay. So you should be able to see this now. 3 things. First is visually explore a gigantic half file in the terminal. Number 2, we're going to run a replay server, like I just mentioned, that's going to rerun every single response back to the browser or whichever client you're using. I'm assuming it's a browser because it's most likely to be a browser, browser. Client. I was browser and client mixed up there. It's an interesting one. Clouser, a bit like Claude. Anyway, I can't take you seriously with the porn stash. Sorry, that was a nice compliment. Porn stash. I'm sorry, it's not a porn stash. It's yeah. So that's the chat up there. If you're not sure if you can see it or not. I just noticed it. I'm not good yet at paying attention to chat. I need to get it more in my visual range here. But it's not a porn stash. No, it's definitely not a porn stash. It's moustache. I did have a beard, but I grow it really patchy. A really patchy beard, and it looks rubbish. So I can grow a great moustache. So I'm gonna stick with the moustache. But thank you. I appreciate I'm appreciating the fact that it looks like a porn stash, because they had some magnificent moustaches, to be honest, particularly in the 70s. Amazing. So what we're going to do once we've got the replay server going on, we're going to set the breakpoints on responses and pause the conversation, which is what I mentioned. We're going to be able to stop and see what's going on. So will this work? I don't know. But I think it's going to be a lot of fun finding out. I think we can make it work. I think we can. So let's jump straight over to Claude, my friend, my mate, my buddy, Claude. All right. Claude code. What we're going to do first, set out to do first, is ask Claude to, actually, let's think about this. What do we want to do? Do we want to ask Claude to go and read the code first, or do we want Claude, let's do some research first. Okay, let's play some research and talk about how we're going to read in a file. How we're going to read in a file efficiently, and what the best mechanism is. So off the top of my head, I'm thinking something like a buffered reader and using JSON decoder, not JSON unmarshal, because that would bring the entire object into memory at once, which is not what we want. We're going to use the decoder and do an item at a time, but I'm not entirely sure if that's the right mechanism yet. So that's where I'm going to start. Now, off the top of my head, well, right, I'm going to go straight in. If you didn't see yesterday, I actually like talking to the LLM now instead of typing. I can actually go a lot faster when I do that. All right. Yeah, the porn mustache chat message came from Twitch. Just so you know, it's not come from YouTube. So I don't think it's anyone who's watching live from Splunk right now. Hopefully not. Louise Fitness 09. Don't think so. Hey Claude. Okay, today we are building a new application, and that new application is called Braid. Actually, I want to pause there. Well, we got Claude put in there. I want to talk about why it's called Braid. Braid. You know, actually, what I'm going to do is I'll bring up my browser. Let's bring up the browser. Bring up the browser. Okay, Braid game. Braid is a video game. It is an amazing video game that was, I don't know, about 12 years ago. I don't know, maybe longer than that. 2008. Good God! Wow, that's a long time ago. Anyway, Braid was built by an amazing engineer called Jonathan Blow, who's very active on Twitter. If you want to go, or x.com, whatever you want, go take a look at him. I'm a huge fan of his work, and Braid, I think, is it's a masterpiece. And the premise is, the story, I'm not going to ruin the story for you, it's just incredible. It's not what you think it is. You know, you're saving the princess, you're not. But the whole mechanic of the game is time manipulation, going backwards and forwards in time, and the leveling in the game is, every level has a different time mechanic. So, you know, you're going forward, you go backwards, you can see what would happen if you took a journey. So you can go back and then try a different journey, but that's got its own problems. And then you try another way and that's got other problems. Things like that. And it just, when I played it, I thought it was just some of the most phenomenal storytelling and engineering at the same time. It's art. It really is a piece of art. If you haven't played the game, you haven't heard of it, go get it on Steam. It's super cheap, man, and it's just phenomenal. It's everywhere. It's on Xbox, I didn't even know. But yeah, Braid, because it's about the manipulation of time. And that's what this tool is. It's taking a HAR file, which is essentially a recorded, history, and being able to replay it, move backwards through it if you wanted. No, maybe you can't move backwards through it, but you can manipulate it. You can pause time. So that's where the name comes from. That's what Braid is all about. Just so you've got some context behind the name Braid. I haven't come up with a name with an icon for or anything like that yet, but it's called Braid. And funny enough, it's not actually based on it's not going to be based on any of the tools we already have. It's going to be kind of standalone. There is one small library we're going to use, which we'll talk about in a moment, that already exists, that's used by Wiretap in a small way. But other than that, it's going to be mostly kind of built from scratch. So that's Braid. I'll come back to, let's go back to Claude. Go back to Claude. If I can click it correctly. There is something interesting happening here. My streaming tool is just freezing up and being very strange. The mouse is behaving really strange when I click around it. I'm using Wirecast. It's a commercial tool as well, so it's paid. It's like OBS is the freeware version, or open source version. And Wirecast is a commercial version. It's not the same company or product or anything like that, but it's just like the difference. And it's actually janking out on me a little bit, to be honest. This is not, maybe I'm doing something wrong, but maybe not. I'm struggling to click around stuff. So back to where we were with Claude. I was in the middle of just starting out our prompt. Hey, I see Roger, my friend Roger. He's watching. Thanks for watching, Roger. All right, back to Claude. Where were we? Braid, yes. Building a tool, lovely. I'll try not to get distracted by this tool, this Wirecast thing. I'm gonna try, but it's in my nature to be distracted by anything that's just janky. So why is it janky? I don't know. Let's fix it, but I can't fix this one, unfortunately. Anyway. So we're building an application. An application is called Braid. So Claude, let's continue on. Now in Braid is going to read in HAR files, and we're going to visually explore those HAR files with a terminal user interface. We'll talk a little bit more about the terminal interface later. First of all, what we're going to do is explore ideas around reading and passing in very large, very large files in Go in the most efficient and effective way. Looking at design patterns and mechanisms for doing that. Now, actually, what I've realized is I am running Sonnet 4.5 with the 1 million window context, or 1 million token window context window. Jesus, I got those words all backwards there. All back. That's a little cue into how my mind seems to operate. I slot words in randomly. If you ever see text messages from me, the words are all jumbled up a lot of the time. I don't know what that's called. Just, I don't know. Anyway, what I've realized is Sonnet is not what I want to be doing here. I actually want to swap over to Opus, Opus 4.1. So the problem that I've got here is that I haven't actually committed this message yet, and I don't want to say all that again. I'm just going to copy it, because if I go up and hit up, I'll go down. Hang on a minute. Now it's not letting me. I can't run any commands. Unless somebody knows how you can run commands mid-prompt, I would love to do that. Oh, Control G. Let's do Control G. Great. Oh, wow. What's going on here? There we go. There it is. Ah, I didn't edit it at all. All right. Never mind. That might have been me, or it might have been a bug. Actually, let's see if that was. Let's see if that was me. Oh, it was me. No, it's me being an idiot. Okay. That was me. So it was me. All right, great. So let's do model. Okay, now we're on Opus. Great. Pasting to this text, the terminal may use dangerous text. That's interesting. Okay. Haven't seen that before. All right, so we're back to where we were. Oh, I think it's the chevron that's giving it grief. All right, so back to where we were. My initial thoughts on this are that we should use a buffered stream, a buffered reader, or it's just a buffered. So anything from the buff.io package would be the most effective way forward. And then using JSON decoder instead of JSON on Marshall, simply because we don't want to read the whole thing at once. We can't do that. Again, that defeats the purpose of the point of the efficiency of this. So what's the most effective, efficient design pattern for loading in extremely large JSON files in Go? Can you please do some research on this? Actually, I'll pause it there, let that come in, and I'll type in ultrathink. When I say ultrathink, it puts a hyphen in a lot of the time. By the way, if you're interested in the LLM that I'm using for text to speech, it's called monologue.2. Monologue with a U, monologue.2. Go take a look at it. It's great. I use it. It works. Sometimes it comes with some weird stuff, but I find that it increases my words per minute to about 150 versus about 75 on a good day. You know, if I'm feeling fresh. Can never seem to get that much faster. Not sure why, but this really improves my words per minute. So we're gonna run the ultrathink with this because we're doing a deep dive, and I always like to make it very clear that I want you to go deep and go wide and think really hard about this. Memory efficiency and speed are the most paramount entities to this application and this tool. If we fail on those, the rest is pointless. Actually, let me give it some. I want to give it some context here. So while I'm doing, I'm going to bring up the browser. I'll bring up the browser for a second. I'll bring up Chrome so I can show you what I'm going to be working with. So if we go back into here and we scroll down and take a look, I'm looking for a repo called Braid. I already created it. There's nothing in it. Let's find it. Where is it? Actually, no, we don't want to look at Braid. There's Braid. But we won't look at that yet. We'll look at something called Haha. And I'm not sure why anyone would have started this. Anyway, this is a fork of another project. I completely mangled it, and I didn't mangle it. I stripped it down, ripped out 99% of the functionality, because what I actually needed from this library was the model, the HAR model, effectively. So this is what this is. It's just a bunch of structs. I can't get that word out. Structs that have definitions for HAR files, request responses, and it works effectively with Chrome. I've tested with Chrome, and I had to modify the original project heavily to be able to support the Chrome weirdness that comes with HAR, because it's not compliant with the standard, apparently. So yeah, I modified it, and I use this in Wiretap, but this is essentially where all the structure comes from. So I want to point Claude at this and say, you read this. Go take a look at the code. In fact, I think I've got a local copy. I can ask it to look locally at Haha. I called it Haha because why not? In fact, 2 years ago, we did a hackathon internally, and it was called the hack was called Hardy Haha, and it was around HAR files again. I don't know. I've got some kind of weird kink for them, it seems, but it was how can we. I don't remember what it was for now. It was doing test analysis on HAR files, but I can't remember what the exact value. Oh yeah, I remember now. Right, yeah, it was interesting. That's actually one of the reasons, one of the main features in Wiretap. God, I forgot all about that. That's really cool. Just so you have no idea what I'm talking about. I'm thinking out loud, basically. But 2 years ago, we did this amazing extension to Wiretap that allows you to serve and replay HAR files. So we've kind of done this work already once in a not so efficient way, because it reads everything in at once. There's a huge amount of memory, and this was always the problem, is we were using Wiretap to replay HAR files for tests, so we didn't have to run the tests against live servers all the time. couldn't quite get it to work. Memory issues everywhere, mainly because, you know, it's trying to load in gigs and gigs and gigs of memories and runners on CI/CD pipelines, and they just don't have that much memory. They're not designed to be huge, gargantuan machines for sucking up, you know, tens of gigs of memory. Well, maybe they are. Some applications require, some runners do, but the ones that we have don't. Anyway, so I don't think it worked very well. But the premise is right. And I think if we solve this streaming problem, we're going to be off to the races. So let's tell Claude about the har file and library, hardy ha ha. When I come back to it, actually, let's just take a look in here, just so we can see, because I can't even remember what's in here. Let's go into the structs and take a look. Okay, so we've got a few classes in there, things like entry, cache state, timings, request, body type, response, name, value, pair, cache info, cookie. Your standard stuff, basically. Basically, it's your standard stuff, innit? Look at that. It's mapped very cleanly to a JSON file with all these JSON tags in here. Very simple. And that's all it is. That's what it needs to be. Ha ha. It's just read a har file. But the problem comes from using this model with a streaming mechanism. Is it going to work? Because it comes in as a slice. I don't know. This is the fun bit. This is where I have no idea if it's going to work or not, or how it's going to work. It's got to work. It's pretty simple. I know it does work. But is it going to be useful? Is it going to actually give you the experience? That part I don't know yet, and that's we'll have fun finding out. So just for everyone's curiosity, I'll be streaming for another 4 or 5. Excuse me. I struggled yesterday with figuring out how to mute my mic, whatever, my microphone when I'm coughing, because sometimes I cough because I drink too much Coke or whatever, water, tea, or I, whatever. Cough a lot, unfortunately. I need to make sure I can mute myself when I do cough so I don't kind of burst your eardrums. All right. We're going to tell Claude about haha, and we're going to tell it that it needs to look at the source. I'll try to see if I got it locally. I'm not sure if I do or not. I'm not sure if I do. So we're going to see what we got in our Go mod. What have we got in the Go mod? There's nothing in the Go mod. All right, so actually I'm going to come back to the Claude and code. You know what, I'm going to start adding some effects next time. Instead of straight cuts, let's do some effects. Let's see if it can handle it. It's still being janky, but it seems to be handling it okay. All right, so we've got nothing in here. There's absolutely nothing in here. So instead of bringing up another terminal, I'm just going to bring up this terminal window here, and I'll do go get. Oh no, go install. Actually, no, just go get. https github.com pb33f, and we're going to do haha. Oh, hang on a minute. I am such an idiot. All right. Oh, we haven't released. Oh, we haven't made any releases. Well, let's just see if we do have it. CD. There it is now. We got it locally. All right, great. So we don't need to worry about doing this. Let's create a Go work file. Go work in it. Okay, we've got a Go work file. Let's do. I think it's use. I can't remember. What does it require? What is it? I'll do this. Oh, there we go. Yeah, that's right. Okay, so now what it's going to do is use the local version instead of using the version that's hosted on GitHub. So we do need to make any changes. Claude's going to be able to jump in there and modify it, which is interesting because where do we put the parsing logic for this? Do we make it part of HaHa? We put an interface in HaHa that allows itself to be streamed, or do we build it into Braid? That's an interesting design question. An interesting design question. I don't know. What makes more sense? Anyone in the chat, please feel free to chime in. I know you're not going to. Because that's not what we're here for, is it? Is to design this together. But maybe you got some good ideas. Should we put parsing in? Do we even make that decision right now? No, let's not make that decision. Let's just load up the context into the LLM, so we're able to make some progress on this. Okay, so we'll go back to Claude. All right. Where are you, Claude? There you are. Now we should see a different effect. Whoa, wasn't that cool? Wasn't that cool? Back in Claude, and let's tell him. All right. So we're going to load up a HAR file, HAR. That stands for HTTP archive. If you don't have that in your model, then you do now. Oh no, you don't. But anyway, and hang on. Excuse me. I'll get rid of that because that's stupid. That's just stupid. We don't need to tell Claude that. I'm just being silly. All right. HAR file. We don't need to tell him what HAR fudge that. We don't need to say that, do we? All right. We don't say that at all. What is Braid? Braid is the application that we are building. So that is from JPOS on YouTube. Braid is the application that we're building today. It's you know what? Tomorrow, for tomorrow's session, I'm going to write up a little document for it. So there's something for you to go and look at and understand the progress. But just for the sake of the stream, Braid is this application we're building that allows us to pass in HAR files efficiently and HAR, they're HTTP archive files, so conversations that come between clients and servers. Excuse me. It allows us to replay these conversations and then debug them. So if we've got a customer that is saying your website sucks, you can say, okay, send us a HAR file, and we can actually see what they saw. That's the point. Just in case you know what, I'm probably have to say that a few times again today because there's people joining randomly and I don't have an about page set up, so I'm sorry. Jump into Discord. Links all over pb33f.io if you're interested. There's a Discord link on all the projects. Just click there, join, and jump into the general channel and come talk to me there. Actually, I don't know why you do that because you're already on YouTube. Doesn't matter. I can see your chat. No one. It doesn't matter. Ignore me. Anyway, let's get back to Claude. So we're gonna load up a HAR file, and you can find the HAR library that we're going to be using. It's called HAR, and it's in. And let's just do /HAR. What I need from you is to go and read all the code in HAR and fully understand how it works and the model design. And then I think I'd like you to do a full deep dive on the most memory efficient way to be able to stream this data in, and how we're going to be able to put that into a really clean, pragmatic interface and an API for us to use. and how we can then implement things like paging and a different functionality beyond that. So don't worry about paging right now. Let's just look at the different approaches and strategies for the most performant and efficient loading of a HAR file in a stream. All right, so I think we're pretty good with this first. So back to the questions here in Dreams API. Wish could offer some insights right now, except to say that to open code with a big pickle is pretty useful and easy to use with your skills knowledge. I can see open code, big pickle. I don't know what that means. I don't know what big pickle is. I know what open code is, but I don't know what big pickle is. Anyway, if you can give me some more insights into that, I would appreciate it, because I don't know what that means. It's just my ignorance, and there's a lot of it. There's a lot of ignorance on my part. I'm gonna fire this off. Let's see what Claude comes up with. So we're running. Oh no, it's still running with. No, it's not. It's running Opus. There it is. I thought it was running Sonic. It's not. We've swapped already to Opus. I've been saving up all my Opus think time on this. Okay, so we got our to-do list here. We're gonna explore the HaHa library. It's not HaHa. It's HaHa. That's the monologue.2. Not coming through with the right diagnosis. All right, I'm going to let Claude just go ahead and read everything in here, because I don't want to be sitting here babysitting it through every would you like me to read this file? Yes, Claude, I would like you to read that file. That's the whole point. Read all of it, so you understand exactly what we're dealing with as a data source. That's the first step. This is what we're putting into the machine. What we get out of it, we'll worry about another time. But first of all, what are we going to do here? We're going to run HaHa and JQ. Yeah. Run JQ. There's a HAR file in there already as a test HAR file that I've been using to test it out on pp33f.io. That's what it's doing now. It's running that. Okay, the next command is going to run JQ, and it's going to look at some of the logs and the entries. Yes, go ahead. Off you go, Claude. And again, and some more. Pass some parameters. Yes, off you go, Claude. Off you go. I'm just gonna zoom in there just a little bit in case anyone can't see it. Yeah, yes, Claude. Keep running JQ. It's really going for it. We did this yesterday, where it took the long way around the houses of trying to figure something out. And we spent maybe an hour yesterday, Claude, going all the way around the back of the houses. Instead of just going straight down the high street, we went all the way around the school route. Every house. We stopped at every house. Yes, Braid is a video game. That's right. It is a video game. And it's also the name of this application. The reason why it's called Braid is because, like the game, we will be manipulating time. Eventually. Not today, though. Today, I'm not sure if I mentioned this already, but today's goal is to get the foundation of everything set up. I want to have the core mechanics of the engine figured out today. Maybe not built, maybe not even, we might not even get to any code today, I don't know. We should do. We should get to some code. Maybe. Depends how fast we go. Depends on how many avenues we need to travel down to figure out the edges of this unknown pool, if you will. Okay. I love this. Yeah. Hang on. Look at this. This is another thing that drives me nuts about these LLMs. Is look at this command it wants to run. Look, web search. Go look for JSON. JSON.decoder, streaming large JSON files, memory efficient 2024. Always with the year. And when he puts comments in, it's always the wrong year. I got like 2023 and 2022 not too long ago. Is that, what year is it? I know, obviously it comes from the training data, but still. I'm going to tell him. No. Hang on a minute. It's... Stop. Wait. Whoa. What's going on here? No, stop. Right. I need to tell him. Claude, buddy. It's 2025. It's almost 2026. We're not too far off of it. Not 2024. Please update your... Or actually... No, don't do anything. Just... I messed it up. I was going to say, please update your claude.md file. We don't have one yet. We haven't built it. So, I'll just say that. Please continue your research, but remember, it's 2025, not 2024. All right, get back to it, Claude. We've got to get the year right. Because we might get last year's solution. Not that this has a date or it's date sensitive. Yes, run those. Run them, Claude. Run them. Big Pickle Open Codes and is Open Code's free model, and it's pretty good. Now I know. I didn't know. It's good to know. Pickles. Oh, didn't know. Big Pickle. I don't think they've used Open Code. I know of it. I've seen it, but I've not used it. The reason why is, well, I got paid access to Claude Code, and it's the best of the bunch, in my opinion. Codex is very good, but it's slow, and it's like having Sonnet 4.5, but slower, but more thorough. I've noticed. I've had it do a whole bunch of code reviews for me, and I felt like it's been pretty effective. Copilot for code reviews is unhinged. It's off the chart mad. Most of those reviews I just ignore because it's like, what? There's some really crazy stuff coming out of Copilot, to be honest. The worst of the bunch so far. Consistently. And I get that for free as well through open source contributions. So I don't pay for my Copilot license, but I don't use it. I turn it off. It's terrible. It gets in my way more often than it helps. Particularly with CSS. Terrible with CSS. Really annoying. Particularly if you're using CSS inside JavaScript, or you're using templates or something like that. Oh man. It doesn't do very well that. So right now, whilst we've got Claude here doing the research, there's not much for us to do really. We're just waiting for Claude to come back and figure out what is going on. Whilst we're waiting for Claude, it's been 45 minutes. I am going to pop off for just 1 minute. I'll be right back, and hopefully Claude will be done. This is like the new compiling code. I mean, obviously we're going to have to compile code anyway. It's not going to take anywhere near as long, but we've kind of moved. It's like the pendulum swinging from centralized to decentralized. It's now I'm putting all of my computation into an LLM, and it's doing all of that crunching for me, and I'm paying by the token. It's like the old days of paying per SMS message. Remember that? Or buying minutes. Used to get minutes on AT&T. That's actually where the iPhone kind of flipped the entire script on the industry. Like, who cares about minutes? It's about data, and we use all of it, and we want to pay about data. Anyway, if you haven't ever seen the BlackBerry Rim movie, I really recommend checking it out because it's eye-opening. Phenomenal movie. Great story as well. All right, I'll be right back in just a minute. I'm going to go and get something to drink, and I will be right back. All right, we're back. And got a comment here from Raj. It says it's late in India. I'm going to bed. Can you please share all the prompts we'll be using for the app so we can go through them in the morning? Yeah, I will. I mean, I'll try to anyway. Depends how annoyed I get with Thor today. Some days we have great days and we make huge strides. Other days, I would throw him in a river if he were real. With a bag. In a bag. Filled with bricks. Lead bricks. And scorpions. No. Snakes. Yeah. But today I think we're going to be doing good. I don't know, he's finished here saying something here. Let's go take a look. Okay. So, what has Claude come up with? Let's take a look. Let's zoom in a bit more. Oh man, that's annoying. Every time I zoom in, it jumps down. All right. Oh, it's got an LRU in there. Interesting. Do we need an LRU? Why would we need an LRU? All right, let's see. Core design principles. Never load in full heart in memory. Stream and process entries at one time. Lazy loading. Only load data when actually needed. Oh, very good. Yes, exactly right. Memory pooling. Reuse buffers to balance allocations. Very nice. Very nice. Exactly what we need. Progressive enhancement. Start simple. Optimized. What? That fifth one is what? I don't know what that one is. Progressive enhancement. Start simple. Optimized based. I don't know what that means. I don't know what it means. All right. I mean, obviously I know what starting simple, optimization, and profiling are, but when we use it in this context, it's like, what? It's like, you know, these two words, these things. Anyway, it doesn't matter. We'll just keep going. Terminal UI. That's our TUI. Yes. We have our virtual entry store, an in-memory index and cache. Nice. Nice. And we have a heartstream processor. It's a token-based JSON streaming. Very nice. And a file reader layer. Buffered I/O with memory mapping. Looking good. Looking good. Looking good to me. All right. Looking good. So, it's got a bunch of strategies for us. Strategy 1. Standard streaming with JSON decoder. From good to best. Okay, so this is the best. The best recommendation is to use exactly what I said. Look, buffer io.reader and json.decoder. Now the question is did I mislead it? Did I say yes, that is the way? Because I said, well, off the top of my head, we should be using something like this. But have I poisoned the well? Have I poisoned the well? I don't know. I'm going to find out. We've got an entry buffer, haha.entry, and pull buffer, which is a sync.pull. Nice. Okay. So we stream entries. Chen, haha, entry, error. Okay. 64 KB buffer. Welcome back. I'm gonna take my hoodie off. I'm a bit hot. I'm a bit hot. So the old brain's getting warmed up now. Brain is getting warmed up. I'm starting to think. I've been thinking all day. Now I'm thinking. Starts giving off some heat. I wish it would burn some energy off my belly. Okay, this looks fine to me. I mean, we're using stream, the channel, decode. Okay. Still Alex. So the pros and the cons. Oh, hang on a minute. I read it wrong. Good to best. Ah, so my solution was the worst. Or maybe it isn't. I think this looks pretty good though. But that's only the best. This is the next best. This is better. Okay. So the previous one was simple, uses the standard library, and it's memory bounded. Memory bounded. So I'm reading here. I just go a bit quiet sometimes. I'm reading, I'm trying to figure out what I'm looking at here. Token-based parsing. Okay. It's still using the decoder, but we're not using buff.io. It's a slightly different mechanism. Load entry. Nice. Okay. Minimal memory for index random access. Yes. 2-parse processing. Seeks can be slow on some files. What file systems? Okay, I'm going to make a note of that because I'll ask you a question in a minute. Why? What file systems? Why would you say that? Where did that come from? Called me old mate. What file systems? So what is that? That's option 2, isn't it? Option 2. What file systems? What are you talking about? What are you talking about, Claude? Okay. Hybrid Sonic SIMD JSON. Oh no, is this a dependency? Sync pool, app data, sonic.api. What is this now? Sonic SIMD JSON. What is that? Obviously it's a dependency. Stream entries in Panorama. All right. What's this? In platform specific mmap. Is that some C library? I think this is overkill, and I don't want to go down this path. Let's take a look at the better. All right. Okay, let's see what else it said. Oh wow. Okay, so we're looking at the different footprints and the different memory and speed. We can. That's pretty. Look at that. Sonic plus memory pools. Wow, that is a huge jump. What is Sonic? Let's take a look at this library. What is this? Never heard of it before. What's it called? Sonic and Sonic SIMD JSON. All right, let's bring up Chrome. See what is going on here, mate. What is going on? What is going on? is it? What's it called? Sonic. Ooh, okay. Oh, it's from ByteDance. Sonic is a blazingly fast JSON serializing and deserializing library. Oh man, this is basically what I need here, isn't it? Fast, fast, fast. Yeah, it looks like it from those results. That's nuts. Fast, fast, fast. Let's see these benchmarks. All right. Sonic Font. Ooh, look at that. Look at that. Look at the difference. That is crazy. Okay. 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 That's crazy. Yeah. Oh, wow. Okay. I didn't know this existed. All right, well. 8.8K. 2 years ago. Huh? What version is it? 1.1. Nice. All right. Okay. Well, I guess that solves that. So the cost that it's saying, obviously, if we go up to the pros and the cons of using Sonic, I'm still going to ask that question about what file systems, but and I like actually the it's zero copy, parallel processing, memory. Yeah. I don't know what's SIMD. What is that? What is SIMD? SIMD and SIMD, single instruction, multiple data. What is SIMD? Oh, the AI suggestion. Single instruction, multiple data. No. Same operations. Okay. All right. So it's simulating a GPU? It's interesting. All right, let's not get I can't get distracted by this because I'm going down a rabbit hole again. Yeah, I need to pull back. So I'm just checking up on chats, see what's going on. All right, okay. I think the solution here, the end solution is right, is using Sonic. Critical optimizations for half files. Let's come back to Claude. All right. So Claude is telling us start with strategy 2, token based with selective loading for the initial implementation. Okay. And then optimize hotspots. That doesn't make sense. What do you mean hotspots? Hang on. Okay, maybe Claude, maybe streamer. Initial implementation. What have we got here? The streamer. Build the index. Always the first thing you need to do. Create an index. You don't know what you got without an index. Phase 2, stream the entry. Returns an error. Stream range in and out, and returns a channel that has entries flowing through it. Page 3, search and filter. Okay. All right. Design efficient file. Okay. This architecture ensures Braid can handle HAR files from kilobytes to gigabytes efficiently with constant memory usage regardless of file size. The key is never loading the full file and streaming what we need, and aggressively managing memory through pools and lazy loading. I agree. Okay. I like this strategy as well. We'll do the simple and then we'll tune it out. I don't think we need to do hotspots. We might as well just think about how we can build it with an interface. Means we can just straight up swap it out with the new implementation with zero impact because we've used interfaces only. That's the right design here, is to use interfaces. So now we know the most efficient way to get JSON in. We can do it using the standard library, using what I mentioned earlier on in the beginning of the stream. Or we can use this Sonic library from ByteDance. ByteDance. What's the license on that? What's the license on it? What is it? Apache 2.0. Okay. Okay. Oh man. All right. Let's start. Let's start with the standard library. We'll build to interfaces, and then we will bring in Sonic if we need to. We'll start testing with 5-6 gigabytes a piece at the upper limit, and then anyway, yeah, we'll see how it goes. But now I know what the ultimate solution would be with Sonic. I'm just worried about ByteDance. I could fork it easily. Do I want to maintain a fork? I'm not maintaining it really, is it? I'm just gating it. Taking a look through some of the dependencies that the project has. Nothing in there. I mean, it's all good stuff, it's just basic stuff. They've effectively used just a standard library and done a load of low-level hard work, saving all of us so much time. It's just ByteDance. Can it be trusted? I don't know. So we're going to build it to interfaces so we can delete it if... because I had something similar like that. EasyJSON was another dependency it was actually it was an upstream project that taken a dependency on it, and I needed the upstream project. So I had to fork the upstream project and remove EasyJSON. If you don't know what EasyJSON is, it's a JSON parsing library that's maintained by a Russian mail company, and there's some shady connections to and from it. It could go wrong. So you remove that as a security threat. All right. I think we've got enough here to start moving on. So now we know how we want to start this off. The next thing is to figure out this, because we're just going to work on the model for right now. We'll put the 2E and all that stuff to one side. We don't need to worry about that just yet. I just want to get this model design with a full set of tests working, so we can see that it can pass this stuff. We can actually validate that and benchmark it. Then I think we're like, okay, great. The model, the engine, the core, the beating heart of the system is done, or at least it's moving. Done is the wrong word. It's never done. Never done. It's never ever done, but it might be moving in the right direction. All right. Okay, so we're gonna start on the next piece, which is, what is the next piece? The next piece. Okay, I think we need to build an engine. with operation 2 using interfaces. Okay, that's good. I'll be right back. I need to do a quick bio break. I'll be back, and then we can kick this part off.
You don't know these streets like we do. 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 Like we do.
All right, I'm back to get this thing cracked. I see your questions popped up from Dreams API, and the question is two questions actually. Can Nix packages, Nix OS play a role in the final outcome in any beneficial ways? I'm not sure how at the moment. Maybe, I don't know. I don't have so the nuts and bolts of this is that this is potentially, yes, it's how it's packaging, right? I'm not sure. Let me rephrase what I'm saying. I'm not sure what the answer is. Saying no is always a bad idea up front because I don't know. To be honest, I don't know what I don't know. I haven't needed it to date for any deployment. All the deployment is handled either through Docker, if you're doing pipeline stuff, or most folks use it for Docker. A lot of people just install the binary. It's available via Homebrew. I don't know. I tried doing Chocolatey, the Windows thing, but it's just rubbish. It's terrible. Terrible in the sense that they put massive gates around the system. That every time you go through this big long setup process and configuration, your build pipeline has to have a Windows machine. It's like it has to be built on Windows because their tooling only works on Windows, so you can't use like Go Releaser. I'm ranting here. I'm ranting because they probably changed it all on like a full right now, but I didn't like it. And I was actually told by Francois, who's actually one of the greatest testers at Princess Beef. He said that we should drop it because no one uses it, and no one does use it, to be honest. Hardly anyone downloaded it via Chocolatey. Not a great deployment network for dev tooling, apparently. All right, number 2. Of all the current cool tools you have developed and maintained, what level of OpenAPI specs do they work with? I think 3.2. OpenAPI is newest. A while ago, there's something new to go along. So I'll answer it in this way. libopenAPI is the foundation, and that's what everything else that uses OpenAPI is built on top of, and that supports 3.2. It supports it fully, 3.2. The other tools all have the latest version of libopenAPI, but they're not exposing any 3.2 specific features yet. So Vacuum doesn't expose any rules in 3.2 specific. For example, one that needs to exist is circular references on tags. Now, libopenAPI does detect the circular references, and it's all available in the index. You can see it right there, but it's not being exposed anywhere. Not in my tools, not yet. I haven't had time to get to it. What's this? Best viewers stream boo. Bots. Look at that. Bots. No, to finish my train of thought there, I haven't exposed those features. I've been too busy building other stuff, fixing bugs and bits and pieces, getting Vacuum ready. Actually, I'm trying to get libopenAPI up to 1.0. We're not quite. I think it's almost there. It's almost there. There's still some things that I know about that I wish didn't exist. Problems that I've tried to sweep to the back of the room, but it's becoming more and more apparent as everything else is cleaned up and tuned up. The rubble that I've left in the corner is piling up, and it's becoming obvious that it's there. So that needs to be cleaned up before it becomes kind of 1.0. But no, to put a specific point on your question, on the answer to your question, no. The only thing that supports 3.2 is the core's foundation exposes 3.2 functionality. They all support 3.2. They can read a 3.2 spec, but you're not going to see anything specific outside of libopenAPI. Not yet. I haven't got there yet. I will get there. It just hasn't. It's because it's so new. It hasn't taken off yet. Not yet. There's hardly anyone using it, and the people that are using it are bleeding edge, and they've most likely got their own tools and tooling to handle this stuff anyway. When the mass market moves towards it, then you'll start saying, hey, I've got a 3.2 spec, I need to use it, blah, 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 blah. And that usually takes a good 6 to 8 months to catch up. It's like now Arazzo is just starting to get some steam behind it. It's been around for about a year now. And as a specification, it's phenomenal because it's like solves a huge gap in the ecosystem for doing workflows. OpenAPI is a description of an API endpoint or a service. It's not how do you use it, how do you stitch it together, how do you create this end result, merging this API together along with other services. That's where Arazzo comes in. It's brand new. And I say brand new. It's not brand new. It's been around for a while. But yeah, it's something that when I say a while, a year. Times are skewed. But yeah, it's been around for about a year. And Frank, who's the author of Ratso, and he works at a company called Gentic now. He was at Smart Bear. He's at he's put it together, and he's like really starting to sell the benefits now, and it makes a lot of sense in the world of agentic AI. And you're thinking, like, we've got Claude here running, give Claude an Ratso file and say, look, this is how you actually do these complicated. It's Arazzo. It's Arazzo, but it's pronounced Arazzo. I was calling it Arazzo for a while, and that just showed my ignorance on it, and I got told otherwise a while ago, actually. So yeah, I'm not cultured or anything like that. I got told I was saying it wrong. Anyway, Frank is the author. And the reason why is I was talking to Frank before it had a name, and we're trying to think of the name. I remember standing in New York. I was talking to Frank, and I was trying to figure it out. I was like, what would it be? And it's like, what would you call it? It's like the workflow thing. You can't call it workflow because it doesn't make sense. Well, it does make sense, but it's just too boring. Anyway, I'm rambling now about Ratso. I'm getting way off target. I'm going to get back to this because we've got to stay focused. We don't have a huge amount of time to get through this. All right. We're now back with Claude, and we have got a good understanding of how we get that data in and how we make it efficient. We're going to start off with my initial design, which is use JSON decoder and the buffered reader. Actually, no, I think option 2 doesn't use a buffered reader, does it? It does use decoder, but it's not. Yeah, okay, let's do that. That's the question I had. All right, great. So we're going to go with number 2, but I want to figure out, when you say number 2, what do you mean? All right, so Claude, I've been thinking about this now. We've been thinking out loud. I've been rubber ducking as well. When I say rubber ducking, I'm talking to the stream. Actually, I shouldn't be putting that into the bloody LLM. Doesn't mean anything. Stupid. All right, been thinking about this now. And here is what I want to do. I'd like to take solution 2 and start with solution 2. It makes most sense. It's a nice blend of power and control. But I'd like to learn more about what you were saying when you said some file systems will be slow. Tell me what you mean by that in a bit more depth, so we can flesh that out a bit more. All right, well, can't just sit here in silence while we wait Claude to pull this together. This is another part that I find that I get, is a problem for me in particular. When you're sitting here and, you're waiting for I'm waiting for the LLM to do something. There's not much I can do at the moment in this particular work stream. So then you can normally flip over to another work stream and start building out a TUI. So you know what? Let's do that, because this is we're going to be going backwards and forwards on this for a while. Let's do this. I'm going to swap over to another terminal. Let's do that. Let's fly over to another terminal, terminal 2, and we're in Braid. Let's boot up Claude. All right, got Claude up again. We've got another Claude in here. Now, normally, if you start working on stuff in the same repo with 2 different agents or 3 different agents, you really start messing things up. They start stepping on each other's toes really quickly, and man, it's a mess. It happened to me so many times where I'm working on a thing and it's like, oh, it's in the other end of the code base. It doesn't matter. Just it's working in a completely different module. It's working somewhere completely different. And I think it doesn't matter. And then I have, another agent come in like I'm about to start doing here. And do something different. But then, they run the tests, and because one agent is halfway through kind of fixing something, the tests fail. So then the other agent goes, oh, the tests have failed. Let me go in there and fix them. And man, the mess that they get into, it's just, if you don't watch it, it's like letting children play with guns. It's just chaos, right? So that's the dangers of running multiple agents in the same code base. Now, Anthropic recommend using work trees, Git work trees. I've used it a few times and it's pretty effective. It can be a bit messy because it's not as nice as you'd think. The premise is, it's a cloned workspace. So the idea is that you have repo A and repo B, and it's the clone of each other, and you can switch between them. You have agent A working over here and agent B working over here, and they can still like push and receive from branches, but they're working in an isolated code base, which is good. But then you've got the conditions that I run into sometimes. I've got multiple different branches and multiple different projects that some are half baked from other features that need stashing and moving, and so I usually try and avoid the multiple work tree thing, because I end up in a mess more than I do in a great solution. But it has worked out pretty well for smaller stuff, brand new things. Might work well here, I don't know, but we don't need it just yet. Okay. Oh, hang on a minute. So we've got Terminal 1 here. We've got Claude has gotten stuck. It says, do you want to create main.go? Hang on a minute. Hang on a bloody minute. No. Look at this. Look. I didn't say build anything, and then it's already gone ahead and done all of that. What are you doing, Claude? What's all this? I just simply asked you about a file system. I asked you about a file system, and you've gone ahead and started, should I start creating a code? It's like, again, this is where if you don't keep your eye on the ball with some of this stuff, you're going to end up in a mess. End up in a big mess. So, file seek performance. Oh, we're down to make... Oh, okay. So we're talking about different types of file systems. I don't think we're reading off of a cloud storage, or really worrying about maybe NFS, maybe NFTS. It doesn't matter. Oh wow, we're worrying about if it's loading over the network. Okay. Oh no, now it's going, oh, how can we make it better? Let's optimize for it. Let's optimize. Oh my God. This is the problem with Opus, by the way, or one of the problems that I see with Opus, is that we're getting away from the thinking it keeps on going towards building, and it overcomplicates every build. Everything when it starts building. I find that it's not that great. It's fast when it builds, but what you get is massively overcomplicated, over-engineered stuff versus the slightly slapdash, slightly sloppy, but pretty good Sonnet 4.5 stuff. That's my experience anyway. And now it's like, hey, let's I haven't asked it to build anything, but it's already refining its own designs based on the research that it did from file systems to try and make them more optimal for friggin' networks. Why, Claude? Why? Why indeed? I don't want any of this. This is not what I asked. I asked you to tell me about bloody file system, and yes, there is a plan and build mode. There absolutely is. You can do /plan. There is. If you do plan. No, actually, that's not it. I think it's a command. Maybe it's a command, but there is a plan mode and a build mode. I don't know. This is new. They must have put this in. Because that's pretty useful, actually. This never used to be there. Man, that's so useful. I had never seen that before. That must be new. Tab to cycle. Well, we got status. Not collected to my IDE. Okay. And then we've got auto compact. Oh, they've changed this. This is new. Been working on it. Love it. Good stuff. All right. That's not what I wanted. I'm looking for shortcuts. Thinking. Planning mode. What is it? Privacy. Planning. No. Plug in. No. That's the thinking is on and off for the tab here. I have seen it. It's like, maybe it's, what is it? Command G? No. Wow. That's not it. That is not it. Memorize file pass. Oh, I'm learning in real time here. I've used it before. I just can't remember. It's like a control. What is it? Control G? No, it's the same thing I just did. Stupid. Was it control P? No. Edit control. Edit prompt. Oh, that's right. Edit prompt is control G. Control T? Shortcuts. You know what? I'm just going to go on the internet. I'm going back on the internet. We're going back to the internet and we're going to ask the internet, how do you, what is it? How do you, what is it? How do you, how do you turn on plan mode? Shift tab twice. Shift tab twice. Ah, there it is. Shift tab twice. Plan mode. There it is. They've changed it. They have changed it. That used to be the command. Wow. Okay. Well, I'm learning in real time. Let me switch back. Let me switch back to Claude because just turn it on. Look, there it is. Plan mode. Plan mode is on. It's shift tab. So you shift tab tab. Shift tab 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 tab. There it is. All right. Claude, stop building. We're not building. We're planning. I've turned on plan mode, which is actually a very good suggestion. Thank you very much, Dreams API. We should have done that. I forgot to do that. Plan mode. Always use plan mode. Oops, I didn't mean to put that into the LLM. All right. All right, we're not building, we're planning. Turn on plan mode. Oh, I don't need to say that, do I? Don't need to say that. All right, turn on plan mode. Before we build anything, we need to continue working on our design. We're not ready to build anything yet. Please do not build. All right, so now we know that the file system stuff is talking about is irrelevant. So I see the concerns that you mentioned about file system loading. Let's just assume for right now this tool is loading locally. If something is coming over the network, we're going to pull it down locally and read it locally. Just for right now. We'll worry about any kind of remote stuff later on, but that should be one of your core assumptions. Before we even think about setting up code and writing code, we're going to be putting together our Claude.md shortly here in a minute. So remember, no code. So the strategy I want to think about is designing out the solution 2, which is the better of the three. The best is using Sonic, which we looked up and is a good solution, but we'll come to that later. We're going to focus on solution 2. Now with solution 2, I also want to make sure that we design everything around interfaces. So when we do want to implement solution 3 using Sonic, we can just straight up swap it out without any changes other than just implementing that new implementation. All the interfaces will be something that are already in place, and everything should just work. So that's a design principle I want to make as one of our core tenets. All right. Okay. So solution 2. I want to also make sure that we keep the separations of concern nice and clean. Pragmatic, but still nice and clean. Okay, so now we've got that, with those bit of context in there. The next thing I wanted to do is actually no, let's get rid of this. Let's just go ahead and build the claw.md now. Let me know when you understand these points and are ready to move on. And just load that into the model. Okay, all right, so core understanding. We're in planning mode. Just design architecture. Nice, yes. Local first, interface-driven design with future flexibility to bring in option 3. Interface, oh yeah, I hate this sycophantic stuff. Really off-putting. That's something that's good about Codex, by the way, in GPT-5, is it's just nowhere near as sycophantic as Opus and Sonnet are. Start with strategy 2, strategy 3. Okay. Yep. Yeah. All right. Okay, ready to put together the design. Okay, so let's put together the design document for the implementation phase. We're not implementing, we're just designing it. Design, a solution for nuts 2 with all of the assumptions we have above. Put together an architecture for defining the interfaces and the structs that we would need for putting together solution 2 for reading this massive JSON file. And I want suggestions, really nice suggestions on a clean way to access that data, to seek that data if we haven't already got that cleared up. And let me know what you come up with, and give me your breakdown and your report. Let's see what it comes up with. Okay, so when I was saying, when we let one agent go because it takes a while, sometimes it does take a while. Can always go over to the other agents, and let's do that right now. I'm going to flip over to this Claude here, and we're going to have this Claude start thinking about the terminal user interface. So the other Claude is doing its thing. We'll come back to it when we've got something to look at. Think about here, and in this place I want it to start thinking about the CLI framework that we would need and the terminal user interface framework we need, because we need 2. We could just get away with the CLI if we wanted to, but then we'd have no terminal user interface, and this thing's pointless. Well, not, yeah, it's pointless. So I am a big fan of Cobra CLI. I've used it many times before. All my tools use it, to be honest, everything, because it's great, and I don't know why you pick anything else. I've tried a few of them, and whilst they're okay, this one is just, it is chef's kiss. I didn't do that. Ah, there you go, chef's kiss. There we go. All right. There's buzzing going on from somewhere. Hang on, let me see what's going on. What is buzzing? What is buzzing? Nothing interesting. Work emails. I need to bring back my... Oh, look. Oh, I've just brought up the WebEx and I can just see that my friend, Protege, I called him earlier, Protege. You need to ping me. You need to ping me and tell me that I can say your name or not. I'm not going to say your name. I can see it now. I'm being broadcast on WebEx internally, and we've got a hackathon room in our office. And I'm not sure if anyone else is excuse me, is watching this. But anyway, I don't know who's watching it, but it's just noticed that. That's what that buzz was. It looks like the feed is slightly behind, actually. Maybe a few seconds, actually. That's interesting. It's like if you see live television, and you know, or maybe not if you've never seen live television. This is kind of an interesting one, but knowing that when the actual TV, actually you can see this if you look at live TV and you look at someone who's broadcasting live TV with a TV in the background, and when you see something happens and then you see it rebroadcast on the TV in the background, it's always about 2 or 3 seconds behind. It's got something to do with aggregation. I don't know. I'm getting distracted again. I'm getting distracted. I need to get back to Claude. Oh, and Claude's already finished in the other one. You know what? We're never going to get over here. Let's just stop thinking about the CLI and just wait for Claude, and I'll tell a joke next time, because we keep getting distracted. All right, let's bring up Claude 1. Claude 1. There you are. My backyard is a construction site at the moment. I'm having some work done. So if you can hear diggers and stuff, I apologize. I don't know how loud it is. I can hear it. It sounds like someone moving a digger around outside my house. I'm not sure if you can hear it. If it sounds like a droning or a whining sound, yeah, it's not me, I promise. Anyway, let's see what we got here. What do we have, Claude? This is a lot. Okay. Nice. Okay, I just got pinged. I just got pinged by the person I was talking to. His name is Ascari. And Ascari is the reason why I'm building this application today, because he presented the problem to me. So just so you know, this is Ascari. You're the inspiration for this whole show. You just see his head swelling right now in the room. Don't get it too big. Don't let it get too big, mate. Okay. Claude has said, I understand completely. Okay, I believe you for now. Let's confirm the key points. Oh no, we're just rid of sugar. That's not where. Here we go. Braid architecture, design, strategy 2, implementation. Okay, yeah, you got that right. It's designing a clean, interface-driven architecture for efficiently streaming massive HAR files using token-based parsing with selective loading. The design prioritizes memory, efficiency, speed, and future extensibility through well-defined interfaces. The art of interfaces. The art of interfaces. That is what I practice. So we have an application API layer. Wow, how did I get that wrong? Application API layer. Simple, clean. Orchestration layer, coordination. Coordinates the index, the cache, and the parser. That's our controller. Index management layer. What? Token parser, okay. Okay. This part seems a bit dubious to me. Application, just if you can't see, I'm going to zoom. Doesn't zoom very well. I'm going to zoom in a bit here. Scroll, 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 da. Here we go. Like the application API layer, orchestration layer, the index management layer, token. That's the part that doesn't make sense to me yet. I'm hoping I'm jumping to conclusions, but I'm coming into this a bit like this seems a bit over-engineered. What is that? What do we need that for? The rest of them all make sense. Let's take a look at our core interfaces. The primary streamer interface, the har streamer. Initialize and build a lightweight index. Initialize. Okay. Yeah. Get entry. Yep. Stream range. Yep. Stream result. Ooh, stream range of entries coming on a channel. Stream filter coming on a channel. Get metadata without loading the full entry. Okay. Okay. Resource cleanup. Okay. I like that. That's pretty good. The index builder. We're going to build. We're going to add an entry. Incrementally add entries during initial scan. Okay. Finalize and optimize index. Let's make a note of that. What do we need finalize for? Finalize. That's very Java. No offense to the Java people. I was one for a decade. But that's very Java. Finalize. Why do we need that? What does that do? We'll find out. And then we're marshalling and I'm marshalling. Okay. The index builder. For caching. Okay. For caching. Why do we need to marshal? Why do we need to marshal if it's all in memory? What? Why aren't we just using straight up structs? Why are there bytes? What are we doing there? What is that? What is that for? A question here, or a comment. The idea of interfaces is completely new to me. Yeah. Interfaces, just in case for anyone in any context, interfaces are the key to everything. In fact, I remember reading a line when I was learning Java, and this was like 2001. You know, I'd spent years doing PHP. Gotta love PHP. In fact, that's why I cut my teeth in PHP. Years doing that, moving to Java, learned to Java, and learned new paradigms to understand. And one of them, the key, I remember just reading this in the book, and it was like just around the turn of the millennia. And it said, if you don't understand interfaces, you don't understand programming. And I thought, well, screw you, buddy. Screw you. I understand how to program. I know PHP. And he was kind of proving my point, to be honest. Joke, of course. No offense to the PHP folks. As I said, cut my teeth on PHP. It's what earned me my cut. It gave me my wings. But interfaces are the key to clean system design. Having a clean, like OpenAPI, it's an interface. That's what it is. It's telling you without a line of code, not a single line of code. It tells you exactly what goes in and what comes out. It tells you exactly what you can call, what you need to do to call it, and the response you're going to get from it when you do call it. That is, in my opinion, the beauty of an interface, because the implementation behind the interface can be absolutely anything. For example, you've got an open API contract, or you've got a gRPC protobuf file, or anything that defines a schema or a definition for an API, or any model really. XML used to be the mechanism we would define things in. We moved to JSON, but XML is actually kind of ideal for defining metadata. I'm not going to go down that path. I sound like a dinosaur. But interfaces is the key to transformation, a clean transformation and clean separation of concerns. Because if everything adheres to an interface, the implementation behind that can be absolutely anything. So you can swap pieces out like Lego, and it doesn't matter that, you know, inside it's filled with lava. It's still a Lego brick. It will still click in. Sure, it might melt everything, but it's going to fit with other Lego bricks, right? It's one of the beauties of having standards. And I find good interface design is essentially setting the standard for your application. You're defining your own standard for the application. If the application of the tool has to work with a standard, it should adhere to that as well. But again, we can go down those conversations another time. Interfaces is the key here. And that's why I'm kind of looking through all of this, because this is where it all will fall apart downstream if we've done this wrong or we thought about this wrong. Of course, we can change all of it. But the code that is generated by Claude, in this case, from these interfaces is going to vary significantly, because, you know, we're using generative LLMs here to spit this all out, and we feed in this context because we're not going to have this model build it. We're going to have another model build it, and it's going to read these interfaces and define the logic based off of that to try and fill in that implementation. If we get this wrong, we're going to get a bunch of garbage and we'll have to start again. So, interfaces, it's the key to building composable, reusable, modular software. That's why I spend so much time on it. That's why I made it my speciality. Or interfaces at every level. User interface, at the application programming level, at the system level, all levels. I think the art of interfaces is beautiful. It's something that we don't spend enough time on. Okay, back to these ones over here. The token parser. Init, navigate, next token, skip, decode. Okay, it's pretty standard. Okay, nothing to talk about there. Entry reader, read at. Okay, it's going to give us an integer 64-bit version. Okay, this looks fine. This all looks fine. Cache strategy. The cache. Yeah, we need a cache. Of course, we need a cache, don't we? And it's an LRU cache. That makes sense. Okay, now I understand why we're using an LRU cache. So earlier when we were looking at the design and it came up, we're going to use we're going to have an LRU cache in there, and I saw that scroll past as part of the planning. I'm like, why? But now it makes sense. I wasn't thinking clearly through it now, but it's in case you don't know what an LRU cache is, an LRU cache is a last recently used cache. Basically what it does is it keeps the most active stuff in the cache, and stuff that never gets called back up is effectively pushed out after n number of iterations. So this is actually a really common like leak code programming. It's like build an LRU cache. You know, you got to know your data structures, and you got to understand life cycle and when to push, and how. And there's a couple of algorithms you can implement that does this for you. It's all very clever. But it really, all it does, its meaning is just like we're looking at these things a lot, so we're going to keep these things hot, and everything else we can pop out of memory and pop it effectively out for garbage collection if you're using a garbage collection language like I am with Go, or you can recycle that memory, collect it up, do whatever you need to do with it, reclaim it in whatever if you're doing it manually. Hey man, do I have any experience with optimistic concurrency? When you say optimistic concurrency, I'm not entirely sure what you mean. Concurrency, yes. Optimistic concurrency? I don't know what you mean by that. If you could explain. I must be missing something. Again, it's not you, it's me, my ignorance. But yeah, let me know what you mean by that. Core data structures, lightweight entry metadata, file offset. Is this what the caching? No. Yes. Yes, I think. Oh, maybe not. The method, the URL, status code, timestamp, milliseconds. Okay. This looks good. Har metadata. Yeah, there's nothing really in here. I mean, there's really nothing much to it, to be honest. It's just a blob of a body and then some structured data around it. Okay, so following up with Dan Pan, I think I've said that right. Please forgive me if I haven't. Basically, adding a property in your database model, such as version, that is changed on every update. As such, if there is a concurrent update where the version has been changed somewhere else, the database transaction fails. Yeah, so in terms of when it comes to databases, it gets different. I'm thinking purely in memory in the model. But if you think about a database and you do, well, maybe it doesn't apply if you talk about in memory stuff. Although I don't think we're going to have that in this use case. But if you're sorry, I'm drifting. I'm thinking about your question here. Do I have experience with doing that in a database? Yes, I've used incremental version numbers that move up to actually fail a transaction. I use it in Postgres. If you fail a transaction, if it moves up or the cursor's moved up whilst you're looking at that version, it'll fail it. So I've done that before on simple terms, but that's about as much as my experience comes with. I either default to the transaction handling in the database, or I put in something like that version increment that would just mark each change has been made, so that if you start the transaction at a certain version, it comes in changes underneath, and you try and finish the transaction, it's moved up, fails. Excuse me. But beyond that, I don't have a huge amount of experience with it. It's not really where my expertise lies, to be honest. Come up a few layers, and I've got a lot more to offer. But when it gets down to the database stuff, yeah, good amount of experience. Can do the majority of things that need to be done. But yeah, beyond that, not really my expertise of areas. So I hope if that answers your question. I'm not entirely sure if it was, but hopefully. Anyway, I'm going to move on to continuing to read these data structures here, because it's only 3 o'clock. My kids are going to be home soon, and the chaos will reign. And I'm probably going to be distracted a little bit. I'll try not to. Data access patterns. Two-phase processing. Open the file with buffered reader. I'm going to use the token parser to scan entries array for each entry. Record file offset. Okay. Do we need to do this part first? Yeah, I guess we do. It's the index, isn't it? It's the index. I have to do it first. Okay, we're getting into some abstract stuff here now, and this is hard to see. This is hard to see because it's actually deep down. So to continue the chat question with Dan Pan is, I'm wondering if the version property should be returned in for an instance on an API endpoint. Okay, so it seems fitting to return it. Should the version property be returned? So are we talking really about API design and the exposing versions to them? Are we talking about HTTP APIs? Because there's a whole series of strategies we could go through on versioning HTTP APIs and RESTful APIs. If you're talking about an API on an object like this, yes, HTTP, okay. So with HTTP, there's a few ways that you can do versioning. There's some bad ways and some, terrible ways and some not so terrible ways. They're all not great, to be honest. The best answer, the very best answer I can give you on how to version your API is don't. Don't version it. Make it something that continuously can be grown and grown. Now you have to deprecate APIs, and then you have to take them out of service. And that's something you can do over time with a strategy. But if you version your APIs, you're locking everyone into a set of models, and to move out of that, it's a very large lift, rather than allowing them to continuously upgrade and grow and grow and grow as you move and migrate your model and grow it over time. So not versioning it and always moving forward upstream with non-breaking changes is the ideal. That's how you should do it. Now, that's a problem because sometimes you can't avoid. You've got an API that has to change, or we did it wrong, we made some mistakes, a million reasons why. So if you feel like you are going to need to do that, because if you design it correctly in the first way, you should never need to, because that's part of the architecture. But if you are thinking about, how do we do this brownfield stuff? We've already got this stuff in existence. We need to put or design it for versioning, or it's going to break in the future. When you think about, different releases, you might have a different use case. If you need to use versioning, the first thing that people normally do is put like a /vx or like v1, v2, v3 as the path prefix. That's a way to do it. I mean, you can do that, which means everything else after this is going to be whatever version that is. Or you can use a date. Microsoft is famous for using a date, not a version. That works too. They come with costs by doing it that way because... sorry, let me know if I'm going off in the wrong direction here, because I'm not sure if I'm answering it correctly. I can continue talking about this for a minute, if you'd like. But I don't know if this is in the right direction. Is this what you're looking for, or am I going down the wrong path? No response. Oh, okay. Looking more about the database version in the API. I think this is more of a specific use case where you're coming, like you've got an HTTP API that's exposing versioning that's bubbled up to the database. This is more of a kind of a schema design question, an architecture question, less about standards and design patterns. If I can't really answer the question in the way that you're looking for, to be honest. I'm going to say, like, if we wanted to talk about the upper level of the interfaces and building a versioning system for an HTTP API or any API, we can talk about it. But then having that exposed in the model, if you've got each model is being versioned, you run into a different set of problems. You've got like a custom revisioning system and a file versioning system at that point, and then you've got a whole different design on your hands. I could talk about that too. I've built my own, but right now I need to get back to focusing on these designs because I'm kind of up against the clock on this a little bit. So I want to move over back. Sorry, I apologize if that wasn't what you were looking for, but send me a message, join the Discord. It's pb33f.io. Click on any of the projects and you'll see a Discord button. Join in there. You can come and chat offline. Right. Back to all of this. It's getting to smart sequential stuff now. This is a little bit abstract. So let's go with these key design decisions. We've got index first approach, a decision rationale, and the trade-off. And then we have O1. Okay. One time ON enables. This is really it, isn't it? It's that we're going to loop through every entity, or scan through every entity and collect the metadata. We're not going to read it. And then we do N1 lookups forever. The trade-off, the initial delay for massive performance gains. Yeah, the initial delay is not really important. I'm sure everyone will be quite happy to sit there for a second or two while it, goes thinking, and then, off you go. Thank you, Dan Pan. I'm sorry if it wasn't the right answer, but come chat with me on Discord. Well, I'll try and help you out the best I can. So yeah, this rationale, this one-time scan, I'm pretty happy with that. And then we got that O1. That's what we want. That O1. Perfect. But we got to go through the ON initially, which, well, I think the point here now is I still need to talk about that finalized question, didn't I? I wrote a note down here. Let's come back to that in a minute. How long would it take to do that index? How long does the index take? I don't know. That's part of the experimentation. We're going to find out how long that indexing takes. Separate metadata from content. The decision. Okay, yeah, we're going to get the frequently accessed fields in the index. The rationale is 90% of the queries need URL status time, not response bodies. That's wrong. The rationale, 90% of queries need URL status and time, not response bodies. Or is that right? Or is it? I've so confidently said it's wrong. But I don't know that it's wrong. When we say queries, why else would you look up? Why else would you make a query? The metadata. Yeah, if it's just the metadata, and then we do the full. Okay. Maybe I'm wrong. Slightly larger index for huge IO savings. Yeah, okay. All right. No, I'm wrong. I am wrong. I'm straight up wrong. Problem is not the computer, it's the person between the keyboard and the computer. In front of the keyboard, whatever that saying is. All right, I'm happy with that. Okay, you've sold me, Claude. You sold me on that. Lazy response body loading. Yes, absolutely. 100%, 100%. Otherwise, this whole thing is pointless. 95% of the half file size is from the body. Yeah, no sugar, Sherlock. Absolutely. Lazy response body loading decision. Never load response bodies unless explicitly requested. Yes. I'm happy with the core implementation. The optimization with the LRU cache makes sense. Well, we'll see. It makes sense theoretically. We'll find out if we need. I'm a little bit concerned. Because if it was, a growing cache, then we'd basically at the end of the process have loaded it all into memory anyway. But I don't know. We're gonna find out. Fun. Because we're not gonna look at every request and response, are we? So, yeah, okay, it might work. Yeah, okay. I'm sorry, I'm just thinking out loud here. Deciding if I like it or not. And I think I like it. I do think I like it. The advanced features, parallel indexing, building compressed in memory storage, memory optimization. Okay, that's not what we're going for. We're going for stage 1. Stage 2, stage 3, stage 4. Okay, so I'm just reading some of this code here. Running fast random access. Filter in the stream. Okay. Huge har. I like that. Huge har. less than 2 milliseconds even for a 10 gigabyte file. That's a bold statement. 2 milliseconds for a 10 gig file? Get out of here. Get out of here. I call BS. Nonsense. All right. Stream image. Okay. Query builder. Query. Where? Oh, this is a nice idea, isn't it? Yeah. A query builder API. Ooh. Now I like that a lot. Status code and method. Yeah, those damn AIs. That's for sure. Crazy nonsense. Yeah, status. Yeah, no, we're gonna need more of that. It's more than just it's the status code. We need the path. We need a path query. It's got to be a path query, and then it's got to be more than that. I think maybe we can just get away with the path query for right now. We'll simplify it. But if we have a query builder interface, it means that we can then extend the dialect and we can add more functionality. So we've got, where and order by limit. It's basically implementing an ORM style wrapper, an interface around this design here, which is nice because it means we can look things up quite efficiently. Query. All right. I like it. Cursor-based navigation. Yeah, we need that. 100%. Can't operate without that. If you don't know what cursor-based navigation is, it's like a low-level form of navigating a very large data set where you move a cursor around a file and just read these bytes and then move to this position and read these bytes and move to position, or you can do that in memory or an object. But that's what a cursor-based navigation means, is looking around large data sets without reading the entire thing. You just need to know where to start and how much to read from. Well, that's the theory anyway. It's my theory anyway. That's what I understand. I'm probably going to get told I'm wrong. Maybe not. I think this is good. I think we're good with this. I'm quite happy with this. I still want to ask a question though. Finalize. What's the finalize? Okay. What? Stop typing. God, getting all mixed up here. Stop typing. We talk now. Can you tell me why you added a finalize method, a signature for finalize in there? I'm not sure what that means. Can you tell me about it? Let's see what he comes back with. And it's lunchtime as well. Well, it's lunchtime on the West Coast. And I am going to go and have a break. I've been doing this for about 3 hours now. Or a little under 3 hours, I think. I don't know. It's been a while. I need a cup of tea. So just before I go and take a cup of tea and pause for a little minute here, let's see what it said about that finalize method. The index builder interface is designed for post-processing optimizations after all entries have been added to the index. Ah, okay. Well, yeah, finalize sucks. No. That's too boring for me. It's too boring. Optimize is too much of a boring word. I know what it's doing. It's basically, you know, kick off the post-processing. But we need something more fun. Some of the things that I do for fun, in the Doctor library, I have 2 new modules. One's already been released, one hasn't been released yet. There's one's called the Changerator, and it takes a bunch of changes and changerates them through the data model. I thought, what the hell does that mean? Well, it's just a fun twist on changing. The Changerator, it changerates. So it takes change objects and kind of feeds them through, feeds them through the graph. So you can see what's changed in an object. I did a little walk through some of that stuff yesterday on the stream. If you're interested, I'm not going to go into it again today because we're not working on that stuff. We're working on a hack. It's hack days, hackathon, and everyone's at lunch, and I'm still talking. All right, let's do this. Change it. Change finalize to, what do I want to call it? Finalize. Not finalize. It's horrify. Horrify. I'm gonna type that so it doesn't get it wrong. Horrify. Now we can make horimatron. Am I coming back later today or tomorrow? No, today. I'll be back today. I'm just going to take a little 20-minute break, though, in a minute. I'm going to take a 20-minute break because I need a cup of tea. And then sit down as well. So I'm standing up at the moment. I'm going to sit down and continue on. Change finalize to horrify. Yeah, no problem. I'm having fun. This is fun. Lots of fun. Horrify. Hurry. No, that's awful. Horrificate. Horrificate. There you go. Just because it's fun, and why not? All right. So now can you build out a complete and detailed plan for building this piece? Everything we've discussed, all of the designs that we've kind of landed on, put it into a full, complete breakdown that any engineer would be able to read and fully understand the rationale behind the design, the processes that we want to implement, which is we build this, this better solution against interfaces that we've already agreed upon, that will then progress into the ability to swap out with Sonic a little later on once we need more performance, and then have the performance. Actually, no, I don't want to do that. Let's pause there, bring that back. That was a good spiel there. I'm going to have another agent build this, so please make it as detailed and as complete as possible so that either agent or human would be able to read it and understand and build against it. Can you actually, what should we call this? This is going to be the model. It's the model parsing. And we need to make a decision. Are we going to put this into Or we're going to put we're going to put it in Braid. Braid's going to do Braid has the brains. That's where the brains are. We're going to need to give it a module name. We need to call it, this is the motor. So I use the same package name in Vacuum. because it's the engine. It's where the engine passes, brings all the pieces and spins them up. That's what this is going to do. Is basically going to take the model from ha and spin it against the file and make it available to the application. That's where the power is here, I think. Let's call it motor. Can you create... Actually, I'm not going to ask you to create anything. Actually, let me think about this. What do I want to say to it? I want it to create a plan, and then I also want to make sure that we give it a name and know what to call it. So this part of the application is going to live in a module called motor, M-O-T-O-R. Not capitals, motor, because it will try and do that and mess everything up. And let's just put that in quotes and then say as part of the application live in motor, module called motor. Can you build a complete... Actually, we've already got it. We've already told it to do it. Wow. Whoa. That was interesting. Gone, and let's just do this. Control G. It's gone nuts again. I don't know how I did that. I don't know how I did that. I don't know how I did that. This part of the application live in the module called motor. Blah, 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 blah. Please name the document. Horrificate.md. Oh, it's great. It sounds awful. It's horrificate. It's horrific. Horrific. Oh, man. Now I wish I'd call the application horrific. I wasn't thinking straight when I called it braid. Nah, braid's better. It's less offensive. Horrific. I love it. Horrificate. And the name of the engine is going to be horrific. Horrific. I love it. We'll call the engine horrific, and they're going to horrificate. I love it. Horrific. I wish I thought of that earlier. All right. No, don't start. Do not build anything, Claude. No building, no coding, no building, no coding. I have told you before, stop trying to build. I don't want you to build. I want you to write the file of the plan, please. Please. Gotta be strict with these things. I want to build. I want to build. Yeah, I know you want to build, Claude, but you're not ready to build yet. We're not ready to build. We're still thinking. Okay, now it's creating horrificate.md. Now it's doing what I'm asking. Thank you, Claude. It's the times like this I'm just standing around going, what is it doing? What is it doing? Let's take a look at that. Oh, we're taking a look at the to-dos here, and it's. I don't know. Those last two we're not doing right now. I'm gonna take a break. It's 3:18. I said like 20 minutes ago I was gonna take a break. This is another drawback. Another comment from Dreams API. I remember unique names for services and products that's easy to remember and easy to market and promote because I've heard of something cool. And then when I go to Google to find it, I can't because something. Yeah, I try and do that a lot as well, but that's really hard. It's like I've thought this really cool name. It's Skimmigabob, and then you go and look online. It's like, look, it's the new Skimmigabob thing. It's like, I thought that was clever. And I've been doing this for 30 years, and it gets harder and harder. I used to remember when you could buy 4-letter domain names. Not anymore. 3-letter domain names were still available. There's a few still available back in like 2000. They were like rubbish ones like ZZY or something. No one wanted those back then. Still going, Claude. Yeah, you know what? I'm going to take a word of advice here from the audience. I'm going to go eat and relax. You know what? I'm just going to leave my. Here we go. Look, I've got this lovely little thing where I can just do that. Look, I've gone, but I haven't really gone. I'm still here. You just can't see me anymore. And then I want to mute my mic. I want to go for some lunch. I'll be back in about 20 minutes. 20 minutes. Alright, we're back online. A bit of echo there. Oh, echo. Okay. 3:23, the music ended. I'm still playing. Might just got very quiet. Some of the tunes in there are terrible. It's all free, DCMA free, royalty free stuff that I took from like Twitch's like recommended stuff. Anyway, I can't even hear it. I don't have the music playing, by the way. I can't hear it. If it's good or bad, I don't know what it is. I have no idea. All right. Where were we? Back in 20 minutes. We're back now. That's about 20 minutes. Yeah. All right. So we're going to. What do we say? What do we get to? This is what you. What did you do? What did you do, Claude? Oof. Oh man, what is all this? This is... thank you. Good to be back. Thank you, Dreams API. Okay. This stuff, look, you know what? I'm going to change the scroller mouse mode. Issues with zoom by. Whee! There we go. Step 2. Oh, I don't want the migration path to Sonic. I want to see the... Where are we starting, Claude? Oh, okay. No, we didn't go far enough. You're absolutely right. I apologize, said Claude. I think there's like there's a book. There's an opening to a book there. You're absolutely right. I think there's stickers going around conventions now with that on it, which is great. Horrificate. Love it. Love it. The Horrific Engine is a high-performance, memory-efficient streaming parser for HTTP archive files, designed to handle files from kilobytes to gigabytes without loading them entirely into memory. This document provides a complete implementation blueprint for the motor module of the Braid application. What's the hashes for? Oh, it's built as Markdown, that's why. Stupid boy. You are a stupid boy. I'm going to have to break here for a second. My kids have run in the house screaming and they're about to start making a huge racket, so I need to go and tell them to not before it gets too loud. I'll be right back. 1 second. 1 moment. Okay. Whoops. Alright, look, I've gone and knocked my green screen over. Look at that, look. I've ruined the illusion. Where is it? It's over here. Oh no, it's over there. Oh, I messed it up even worse now, look at that. I love it was even worse. There we go. There we go. Fixed it. The illusion is back. The mesmerizing effect. I'm really in the computer. I'm really in front. I'm sitting here right in the terminal. For real. For really real. I really am. Yeah. Anyway. Horrific. Love it. Key requirements. Memory efficiency. Number one. Number one priority for this tool is to be efficient with memory. Speed. Sub-millisecond entry access after initial indexing. Scalability. Handle half files from 1 KB to 100 gigabytes. I think that's a bit excessive, to be honest. I really don't think we're going to be doing 100 gig in the browser. I just, you know, maybe over time. It seems excessive. I can't see it. Can't see it. Local first. There it is. Let's get local first right. Then we will worry about the rest of it. Let's get that bit right. We get that bit right, the rest of it will follow nicely. Here's our module structure. With the motor. With horrific. No. 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 I don't like that. Okay, before I just start ripping it to shreds, let me make a note of it. We'll come back to that. Horrific should not be another module inside a module. What's the point of motor? In this design, there's no point of motor. It's stupid. Bring my magic red book. It's my big red book of mistakes. This one is a mistake. Just turn right down the module name. It should be not. It shouldn't be structured like that. But there's probably more that I want to change. But I don't want to start like ripping it apart now because we won't mess up the context. The core design principle. Everything else in there is fine. I mean, yeah, it looks good. Interface segregation. Every major component is defined by an interface, allowing implementations to be swapped without affecting consumers. This is critical for our planned migration from standard library JSON to parsing with Psych. Yes. Yes, you are correct, Claude. That is absolutely right. Well done. You get a cookie. Or in this case, electricity. You get a GPU. Congratulations, there's a 590 with your fit. You keep dropping my pen. Oh no, is that some kind of omen here? All right, two-phase processing. Phase 1, build a lightweight index by scanning the file once. Yes. Use the index for 0 on random access for any entry. Yes. Lazy loading. Never load data unless explicitly requested. Yes. Response bodies, which is 95% of the file. That's a guess, isn't it? You've made that up. But you might have taken it from the example that I had, but that's not necessarily true. But yes, it is a very, very, very large part of it. Loaded only on demand? Yes. Yes, all good. We're going to reuse allocated memory through sync.pool to minimize garbage collection pressure. Yes. Yes, this is good. I like this. It's clean. And we're going to start with the standard library and we're going to optimize based on profiling. Yes. Yes, we are. Yes, we are. So let's take a look at the application architecture. What have we got? We've got the top. Application layer. The Braid TUI application. And that's for another day. We're not coming anywhere near that today. We've got the motor module API, the high-level interface. Yes, that's a clean separation. And then we have the horrific engine. The horrific engine. I love it. Ah, man, I wish I'd call the whole thing horrific. Now, I still could call it horrific. No. Maybe. Ooh, maybe I'm going to change the name. I like horrific. I love Braid, but I like horrific more. It's more fun. But it sounds a bit awful. Braid, at least, has a meaning behind it. It's true. That's the original meaning behind it. The whole thing is bad time. And horrific is just a play on words. Oh, branding is so hard. Branding is hard. The two biggest problems in computer science. The first one is caching, and we've got caching in here. We've got the cache manager, and we've got an LRU in it as well. Our least recently used cache LRU. And then we've got cache manager. So the first hardest problem is caching. Got it solved. The second hardest problem in computer science is what? The audience says, what? Nothing. Silence. The second hardest problem is naming things. Naming them. And that's why I'm getting kind of stuck on this, because I really like horrific. But it is a play on words, and it is not a meaningful thing, and Braid is meaningful, and it's easier to say, and it's more memorable. All right. That's what we're going to do. We're going to stick with Braid. Stick with Braid. Naming. Not starting from scratch. Comment from DS. Cool initials, by the way. Not starting from scratch. I don't know what you mean. What do you mean not starting from scratch? Alright. Let's look at this architecture. The horrific engine, the orchestration component. It coordinates all these systems below. The index manager, the entry reader, the cache manager. That makes sense. Oh, the original Dave. Oh, you. I know you. I know you. I know you. The original Dave. Yes. And I am Dave Prime. My name is quobix. Out here on the internet. You know the inside name. The outside name is quobix. But yes. Dave Prime. Makes me sound like a robot. Maybe sound like Optimus. Like I'm a prime. That's nice. Can run with that. Here we are. Anyway, get back to this architecture. Time is ticking. Tick tock. Tick. Bloody tock. Here we go. What we got? Token parser. Yes, of course we need that. The file I/O component. Buffered reader plus the seeker. All right. So far, the only problem we've got is the structure of with the modules being put. It's stupid. It's just double nested it. We don't need that. Let's take a look at some of these interfaces. What have we got? Entry access. What? Data flow. Oh, okay. It's the data flow. Initial index building. Half file to the buffered reader. The buffered reader to the token parser. We take from the token parser to the index builder, and then that gives us the index. Great. Now we've got an index. Now we can start doing 0-1 lookups. 0-1. N1 lookups, not 0-1. God, I always get the N and the O mixed up in my head. Mix them up. So we've got our request, we've got our lookup, we've got our file seek. Where are you? From the index, we go and read that. From the massive file, we pass it. We then create an entry object out of it from that passed set of bits. We cache it, and then we generate a response. Sounds good. It sounds good to me. What is missing? What is missing? Has anyone got any ideas? I'm looking over at the camera that's currently placed in. We've got a big room in Cisco, in Splunk Cisco. It's a Cisco building now. Used to be Splunk building, but it's now owned by Cisco. And we've got a big training room. And I'm looking over it right now. Just looking right now. I can see 3 people. There's 3 people in there. Maybe there's more. I don't know. There were more people in there. Is it that part of the day when everyone's like, oh, I'm tired, I'm going home? It's when you got to dig in. It's when you got to go harder. Dig in. It's 4 o'clock for me. My kids are home. Got to dig in. Let's keep going. I'm not ready yet. We're not done today until we get a working unit test of this streaming a half file. Got to get that far. With the half streamer, get entry, streaming range. Well, we've seen all this before. This is all fine. This is all basic. It's all pretty standard. The index builder, pretty standard stuff. Tokens, navigate, path. What's this? Hang on. Navigate to. Moves the path to a specific JSON path. Whoa. Oh. That's weird. Why would you do it that way? Navigate to. Path. Log entries. Navigate to. That's another weird one. What? Navigate to. Log entries 5. I mean, it's a JSON path. Is it just we're just going to provide, I mean, the signature of the API would be better provided as a JSON path string. Or do we care? Tricky one. So what I'm deciding here is whether or not I care about the fact that navigate to is taking a slice of strings, which is effectively an exploded JSON path, and you can use a delimiter in a JSON path. The standard is a period. So if you just have a string, like in this case of the example, it's got log entries 5, it would be log.entries bracket 5 close bracket. Basically, yeah, okay, fine. I'm not gonna rotate on this. Just fine. It's fine for now. When we start building high-level APIs, and maybe it won't be fine. Maybe we need a simpler one, but it'll be fine for now. We could do navigate to JSON path, and there we go. Problem solved. All right, next token. JSON token. Okay. Decode. Entry reader. Read at. Yeah. Start here. Read for this long. Get an entry. That indexing logic is going to have to be crisp. As long as it's crisp, this will work. Read the partial offset. Yeah. Stream responsibility returns video. Okay. A read closer. All right. Read metadata. Okay. Yep. Ooh, cache strategy. Problem number 1 in computer science. Get, put, evict, clear stats. Okay. Super basic. And super clean. From an interface, that is. It's how well we implement it underneath. Although this stuff is all so mechanical. It's so mechanical and it's so over-rotated on in training material that this algorithm has been written 40 million times by 50 billion people. That's possible. Maybe not. Anyway. Filter. Do we need to worry about filtering and prefetching? Learn? Predict? What the hell is that? Come on, man. We don't need this. Maybe we do. No, we don't. No, we don't. No, we don't. We don't. This is opus again. Hey, let me make it more complicated. Let me throw in a nuclear reactor here just for fun. Come on, this is Opus being nuts again. What's learn? Why? Come on. Learn what? It's a static file. Learn what would Opus, you're letting yourself down again. You do so well and then you do stuff like that. That is stupid. Alright, we don't need prefetch. I'm gonna get rid of that. So hold off on 6 and 7. Because they're dumb. They are dumb. I'm writing that down because I'm going to say that. In the context of this exercise right now, I have not said anything about any of this stuff. It's making it up. Trying to be clever. Over engineering. Don't need any of it. All right, the entry metadata. This is what we're keeping in our index. This is also essentially the core of how Splunk works, funnily enough. Indexes. And we have our own custom. Anyway, stop talking about that. Let's talk about this. We're hacking code. Entry metadata. We've got a file offset. We've got our length, our method, our URL. Yep. Codes. Timing. Yep. Size information. Yep. These are just numbers and bools, strings. URL could be. It's not really going to be very big. I mean, sometimes you get paid request to query strings that have a body in them effectively, but that's what the new query HTTP method is designed to solve. But okay, no, it's fine. It's fine. It's pretty clean. It's pretty lightweight. We wouldn't use up too much space. All right, the index is the master structure for fast lookups. The master structure. That deserves a closer mic version. The master structure. Like that. Yeah. Alright, we're looking at files, sizes, hashes, versions. SHA-256. Yeah, do we need that? Do we need a 256 on this? Seems pretty heavy. Don't need it to be cryptographically secure. But an MD5 suffice. I know, never use MD5, but this is not. This is just literally just a way to take a body. I mean, do we really care? What's going to be faster? Let's take a look at that. Let's ask that question on the 256. Do we need to hash with that, or could we use quick hash? I know there's that library out there. What's it called? God, let's go looking for it. Let's go searching. Actually, do we need to go searching? Yeah, let's go searching because I can't remember what it's for and I don't look in the code. Let's do that. Ready to fly over to Chrome. And, oh yeah, we were turning on plan mode. All right, let's get rid of that. What is SIMD? Okay. Super fast hashing. Strings, that's important. Strings. Go. Fast hash. Is that it? Is that the one I'm using? Or is it X hash? No, that's not it. That's not the one. Is it X hash? What is that name? GD. Is this it? No. Man, that's annoying. I can't remember what it is. I can't remember anything. Too much weed. Too much of that. Is it XS hash? No, that's not it. You know what? Let's go. Let's go looking for it. Oh, I've just lost all my chat here. There we go. Let's go take a look for it. Let's go in here and take a look. How are we going to get in there? That's the question. How are we going to go find it? Let's do this. I know where I've got it. I think I know. go into here, and then we'll go and take a look in the doctor. I think I'm using it in here for something. In here? No. Maybe it's in the validator. Somewhere, because I'm definitely hashing strings really, really fast. And I've got my own custom algorithm that I've used in libopen that does hashing. It hashes all the properties of the object, which is lots and lots of fun when you're going to do it in a hyper recursive polymorphic way. But it's also a bit slow. Where is it? Is it in vacuum? Can't be in vacuum. Can't be in vacuum. Is it in vacuum? It might be in vacuum. Where are you? You're not in there. There it is. There it is. XS hash. There it is. All right. XS hash. Was I just looking at this? Wasn't I just looking at this and I said, no, that's not it. And it was like a Google link. Google code link. What was I looking at? This. Hang on a minute. That is right. Or is it? Oh no. No, this can't be right. Oh, the internet. Don't you just don't you love it? All right, this is it. XX hash. Super fast hashing. We're going to lose time. We're going to lose performance if we use SHA-256 because it's, it was great, but it's not particularly fast. This is fast. So let's talk about XX hash versus 256. SHA-256. It's important. It's important. Important. All right. Let's move on. Back to Claude. Come on, Claude. Let's go flying over there. Whee! Okay. All right, back to the index. Creator. Okay, that's just a struct. Yeah. Oh, okay. Indexes. We're gonna get the entries, total entries, string table, deduplicated strings. Okay. Okay. Yeah, that's fine. Internal memory. This is something that I've seen like appear all the time when I started using AI. Is string internal for performance, particularly in Go, and it does actually help considerably. I never used this technique before, but AI spits this out all the time. It might just be a gap in my knowledge, but it really does help with performance. Yeah. Okay. Well, that's just basic. Streamer options. Ooh. Streamer options was going to configure our horrific engine. The file handling. The buffer size. 64K. Oh, that's nice. We can change the buffer size. Ooh, I didn't think about that. Should have thought about that. Thank you. Thank you, Claude. Good idea. The index cache path. Who cares? Yeah, sure. Okay. Rebuild the index. Force rebuild even if cached. Okay. Max index memory. Let's talk about that. What do you mean max? That's dangerous. I don't want that. I don't want you to put a limit on memory. Let Go do that. That's what Go's got a runtime for. It's stupid. What are you doing here in that case? Again, it's being too clever. You're being too clever, Claude. You're stupid and amazingly clever at the same time. That's possible. Yeah, it's possible. You can be immensely smart and stupid at the same time. No max memory. No max anything. No max, no ceiling, no limit. Just like 2 unlimited, you remember? No. No, there's no limit. Just like that. If you were born anytime in the last 20 years, you probably have no idea what I'm talking about. Prefetch. Stupid. I'm just making some notes here. Just is what I want to tell. This is the feedback I'm going to be giving, so we can clean this up, because there's good stuff in here and there's some stupid stuff in here. No max memory, prefetch. No max anything. No memory pool. No, Claude. No memory pool. What are you doing? We don't need to manage memory. You stupid. No, I don't need to limit it. It's not the point. The point is to be efficient with it, not to limit it. Streamer stats. Oh, that's nice. Yeah, a little hits and misses. Evictions. Yeah. That's all good stuff. All right. Let me load of stuff in here. Okay. Now let's give the LLM some feedback here. All right. Where are we? Oh, we're over here. There we go. Okay, Claude. Got some feedback for you. Things we need to change. The first thing is the module naming. You've got motor and then horrific as a submodule underneath that. We don't need that. Please don't create a submodule called horrific. Just motor. That's fine. That's what it needs to be. So move it up, please. Then go next. I want you to hold off on the whole concept, number 6 and 7 in the plan, the whole prefetching and learning. And I don't know what that is. I never asked for it. Please don't build that right now. We don't need it. And I don't need to build hooks for it because I don't even understand what it's for. It's something you've made up. Please don't put that in. All right. Now, let's move on. What else have we got? Ah, yes, hashing. Let's talk about the hashing you've got in there. You've got a SHA-256, and whilst that's fine, that's no problem. It's all good, very normal. I'm curious, is there a faster mechanism that we could use, a faster hashing algorithm we could use? Would MD5 suffice? I know MD5, I know problem, but for this use case, does it make sense? And then moving on, there is a very fast hashing library that I have used before called XXHash. Could you look at that? Look at the code, and determine whether or not that would be faster than either MD5 or using SHA-256. Let's make sure I got XXHash right. No, it hasn't done that. It's got 2 double X's, so let's just type that in. Yeah. All good. All right. See how much faster this is than just typing? God, it's so much easier. So much easier. And what comes out is like 99% really good. You know, sometimes you've got to edit it a little bit, but AI, love it. Just sitting here, just talking to a computer. It's great. It doesn't answer back. Or say that you've got a porn moustache. All right. I think that's it. Yeah, just to follow up. Actually, I don't know. Follow up. What am I talking to? It's like I'm talking to my boss. No. There's some. You got max memory in here and like max cache memory. And like memory pool sizes. we need to scrap the whole idea of max anything, and memory management in general. I don't want that as part of this tool. There should be no memory management or maximum sizes on the pools or anything like that. I'm not worried about working inside super limited, memory limited applications, because it doesn't make sense, you know, to be running like 10 gig of analysis on a machine that's got like 50 megabytes of memory. I'm okay living with that kind of limitation. So I'm going to ask if it understands, and then we can update the plan and then take another quick look. Let me know if that makes sense, and can you update the plan and the interface design according to what I'm talking about here? No, let's just get rid of that. Accordingly, let's say that. Accordingly. All right. Off you go, Claude. With that, I'm going to take a quick bio break. I drank too much tea. It's gone straight through me. I'll be right back. Be right back after these soothing words from no one. Okay. Let's see what we got. Let's see what we got. I'm not going to go through all of it again because I don't need to. Okay. Oh, let's see what it says. I did a website. Oh, hang on. I'm too good to keep going back. Absolutely. Your feedback makes perfect sense. Of course. I love you, quobix. Simplified to just motor. Thank you, mate. Good job. Prefetching. Learning. Removed. You're right. This is over engineering for the current needs. Yeah. Hashing investigation. Let's see what XX hash returns as versus SHA-256. What comes out? At the top, based on the research, XX hash is absolutely the right choice for our use case. Well, look at that. The hash algorithm recommendation. XX hash, yes. 15 to 30 times faster than MD5. Oh, no, what's MD5? Yeah, look at that. MD5 is fast, but not as fast as XX hash. For file integrity checking, not security, XX hash is perfect. Yep, that's what we need. We don't need secure here. There's no security required. It's just making sure that we have a way to determine. We can do a hashing is for, right? We can use it for either for a lookup or to ensure that that payload is correct. Yeah, it's the most mature. Yeah, XX hash from Cispar. Who's Cispar? Who are you, Cispar? You make a great library. Congratulations. It's great and fast and exactly what we need. Thank you for your contribution. Memory management. Thank you. Got rid of all of that stuff. We have a nice clean structure. Thank you. Get rid of all that rubbish. Prefetch and filter we don't need filter functions. We might later, but right now it doesn't make any sense. We're not building it. This is not designed to be extensible. This is just going to be like a single shot tool. It doesn't need to grow. It doesn't need to be expanded. It doesn't need to be bigger than it is. It has one purpose and focus on one use case. The cache strategy. No memory limits. All we've got is get, put, clear, stats. Perfect. Nice and clean. Delete, 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 delete all the crap. Delete all of the crap. And these are our indexes. Yeah. Streamer options configures the horrific engine. Yep. Okay. This is. Wait. What is this? Why have you put a cache strategy in there? Was that in there before and I missed it? What's that all about? What is that all about, Claude? What do you want about? Do we need a strategy? Why would we need a strategy? Hang on a minute. Let's see what he says. They, it. It's not a they. It's not anything. It's not a human. It's a thing. You're absolutely right. Oh, you're absolutely right. I need to make like a button on my Stream Deck that I can press, and a little confetti or something is going to go da-da. Actually, I want to focus on that this week. There's something I'm going to add. Every time Claude says that I am absolutely right, I am going to press that button. See what happens. You're absolutely right. You're absolutely right. But here's the thing. The cache strategy was for when you access an entry, we pass it from disk and keep it in memory. If you access again, scrolling back in the TUI or viewing details, it's instantly available without repassing. Without the cache, the user views entry 500, but I want the cache. The cache might be unnecessary complexity. No, I don't think it is. It's particularly if we're doing fast seeking. Well, actually, maybe not. Maybe we should just strip out the cache altogether. Do we need a cache? Got to think about this one. Do we care? If you need a cache, like it says, if you're scrolling back in around the har files and you're looking around and you're scrolling up and down quickly and you're paging quickly and you click on something or hit select something, we've already loaded it before. Why do that work all over again, right? It's just, we can have it instantly available. But if the level of effort required to, and by the way, that cache will grow, it will grow over time. Eventually, if you looked at everything, you'd fill up the memory, which you wouldn't, because it's not the point. But if we get rid of the cache, then there's no memory growth. It's just seeking every single time. And we're just rereading from the file, the same file every single time from the same read seek point and the same number of bytes. But the question is what's the cost on that? And we haven't built any code yet to do any benchmarks. And the question is how big are those reads going to be? Because that's, well, let's do that. Let's ask. Okay, Claude. So to figure out whether or not we need the cache or whether we should drop it, let's ask this question: what is the overhead on reading from a file if you know the start point, the seek point, and the number of bytes to read from, so you know exactly where to read and how much to read? How much of an impact is that going to be for us versus caching it and just pulling it straight out by using a lookup? How much extra? Because I'm thinking that the cache is going to grow, and sure, we can have a cache strategy like an LRU where it doesn't grow, it only grows to a certain point. But it still means maybe we have an LRU. No, I think we need to keep it. We keep the LRU small, but it means things you're going backwards and forwards and looking at. Maybe let's say like 50 or 100 records to make it maximum that size. Then we should keep the configuration. I'm just thinking out loud here. Sorry, folks. This is. I've just realised that I've gone on. Did all of that. I was rubber ducking. I was giving the prompt. I was building a prompt and rubber ducking at the same time. That's not a good idea. Sorry about that. Shouldn't do that. Don't rubber duck and prompt because you create mayhem. So going through the thought process. This is one of the things I'm actually really starting to learn that is helping me. This is one of the surprises about doing this streaming stuff, this live stuff. I'm rubber ducking everything. I'm thinking, because I'm saying it out loud. I'm taking my internal thoughts and making them external. So, there's something for you to listen to while you listen to my stream of thought. But it's also helped me think through the problem a little bit better. And I'm actually building things a little more carefully because I'm rubber ducking them out loud. I don't get to do that very often because I don't have face-to-face interactivity a lot of the time. I'm not working or sitting next to people who are coding on the same thing. Very interesting, because now thinking about it, I do want a cache and I do want an LRU. I do want to be able to, because it doesn't make sense to do it each time. But then for the sake of simplicity, we don't need to build that stuff up front. We can plug it in with interfaces. All right, that's the solution here. Well, I want a cache, but I want to make it pluggable. So the cache has to be pluggable. It has to be something you can stick in there without it being necessary. So we can build all the core logic, and if there is a cache, it will look in the cache. If there's no cache supplied, no lookup. That's the instruction. All right. Okay, Claude. So I thought this through. I've been rubber ducking it, and the decision is I want to keep the cache. I think the cache is important, but I don't think we need a cache strategy. I think we should just keep it as an LRU. All right, we don't need to make it a fancy cache. But I also want to make it, it's pluggable. So you can add a cache, and then it will use the cache for lookup, or you can say use cache as a configuration, or you can say no cache, and it'll just run the raw logic, and it will just bypass that branch of logic that runs through the cache and does a lookup. So the cache is optional. We should cater for it. We should build it, or more importantly, for this first build phase, we should build the interfaces for the cache, which we've already got. We don't need to build the implementation just right now. So as long as we have the interfaces put in place, we can move forward, and then we can come back to the cache later on. Let me know if that makes sense. Oh, hang on a minute, it's gone all... You know what, I don't know, let's just paste it because I can't read that. I don't know what the key code is to view pasted text, like when it does that, without clicking on it. I've clicked on it and it does it, but I'm not sure what the key combination is yet. Anyway, that looks fine. Okay, so what are we going back with? That makes perfect sense. You're absolutely right. There's the button. I need the button again. Like, da-na. I need that. I'm gonna make that tonight. Actually, tomorrow morning. That's what I'm gonna do, not tonight. I need a break. But yeah. Okay. Okay. Single cache implementation. Yep. Optional pluggable. Yep. Interface first. Perfect. And a simple bypass. Yes. Hang on a minute. No, that's fine. No, it's fine. It's fine. It's all good. Updated the cache interface. Cache provides optional caching for past entries. Get put clear. That's it. No strategies, no complex configuration. Except we do need a configuration. That works in Streamer with the cache. Oh, there it is. Okay, I'm happy with that. I think that's it. I'm happy with this. I think this is what we need. Okay, all right. Now for the fun part. Well, not the fun part. This is the part where Paul goes off and does a bunch of work, and I'm going to take a quick break once it's running. That is. But the first thing we need to do is set the model. Let's set the model. And we're going to change it to Sonnet 1 million. Actually, before we do that, sorry, Claude has asked me a question. Before I change the model, should I update the full design document? Yes. Yes, update the design document with everything we've discussed. Make it ready to go, ready to build, and then let me know when you're done. All right, I'll wait for it to finish this before I change the model. It shouldn't take long. It should only take a second. And then let me change the model, and then we're going to get Sonnet 4.5 to do the building, because the thinking is done. Like we've figured it out. We've figured out the design. Now it's a case of implementing it. And again, that's mostly pattern driven. And this is where, you know, you just let it cruise. And one thing I'm also going to do is have it run the We'll have a performance code reviewer agent as well. It's going to run that while it's building, and then it's also going to build some tests to make sure that it's valid. Then we need to figure out, actually, we need to think of this about this now. So how are we going to test big HAR files? We're going to need to get the AI to generate some realistic HAR files for us between 1 gig. You know, not many of them, because they'd be too big, but let's say we'll do a selection. We'll do like one's too small. 5 megabytes, 50 megabytes, 500 megabytes, 5 gigabytes. Yeah, let's do that. Let's see if that handles that. All right. All right. I think we're ready. Ready to go. Come on, Claw. We're waiting for you now, mate. Come on. Hurry up. I need to get like some Some mini games. This is the mistake I made last time. The mistake I made last time was like, okay, whilst that's cooking, let's flip over to another agent and we'll start over here. And then this one pops back. I was like, oh, how this one's done? It needs a question. And I flip back over and then we get stuck here for a while. I know it takes a while. It takes a few minutes sometimes, but I think the cleanest thing is just to sit here. Actually, you know what I will do? I've got another terminal up here. Where is it? It's got vacuum on it at the moment. Let's spin over there for a second while we're waiting. And I will show you what I've... let's clear that. And let's do CC usage. And what it's showing you here, this is my Claude Code usage since the 12th of October. That's a month ago. So it's the last 30 days. And you can see which model, let me zoom in here a bit so you can see it a bit better. You can see which model I've used. 4.1, here's all the inputs, outputs, caching. Number of tokens is really important. That's how much it would cost. So I'm not using the APIs. Obviously, I'm using Claude Code here, but I'm using my Claude Max subscription, and I don't have to pay by token. So these costs don't really apply. I'm not paying these values, but this is what it would cost if I was running the API. Look at that, 1,300 a month. What is that? That's 1.3 billion tokens. What is that? Is it input or output? What is that? That's just total tokens. 1.3 billion tokens. Oh, that's a lot. That's a lot. 1,300 a month. Crazy, huh? Crazy. Expensive. So expensive. All right. Claude is asking us, wait. Would you like to proceed with what? Hang on. I don't know what's going on here. I'm just asking. Oh, yes. Sorry. Please continue. Wait a minute. I don't know what I was doing there. Asking me to do what? Allow it for all files? What are you talking about? Please don't start building. Please don't start building, Claude. Please don't mess up now. Don't mess up now. Yes. Manually approve edits. No. Auto accept edits. Yeah, let's do it. Let's live dangerously. Live dangerously. No. What are you doing? Don't build! Claude, just write the document. Just write the document. With all the changes we've been discussing, I never said build. I never once said build. Stop building. We're in plan mode. Stop it. I know you're itching to code. I know it. I know, mate. I understand. But stop. Just the document. Can't stop it from just wanting to just code. I want to code. I want to code. I am a machine. I must code. All right, the document is done. Fully updated. Okay. Well, where? Where did you write it? I don't see it in here. Is it in? Hang on. Let's bring up the terminal one and code so we can see what I'm looking at here. All right, here's our haha project. Whoops. And I don't see. Where's the file, Claude? Where is it? Where is it, man? Where did you write the file? I don't see it. It's not there. Unless I'm just going mad here. It has been a long day. Why does it take so long? 32 seconds to tell me where you put the file. What are you doing? Oh my god. All I want is my horrificate MD document. And Claude is now taking 1.6 seconds and 2.7 thousand tokens to tell me where it's written the file. Or it's going ahead and coding again. I don't know. It's this point where we're running with AI for what we've been going now with this session for nearly 4 hours, and it's starting to go a bit weird. It's not listening anymore, and it's starting to do some stupid stuff. This is why I need this file written so we can clear the context and start again, basically, but with a full, ready-to-go design document with everything we need to build already laid out and all the design decisions. Now it's taken 1 minute, nearly 2 minutes now. 4.5 tokens. Was it just spending money just for the sake of it now? Who knows? Who knows what it's doing? But it's at this point where I start getting annoyed with AI. Really annoyed. It's like, can we just move forward now? Like, let's go. We've done the thinking. We've spent all day thinking. Let's go. Let's go, Claude. What are you doing? I want to escape it, but I feel like I'm just going to sit here for another 3 minutes while it's doing whatever the hell it's doing. I don't know. What are you doing? What are you doing? Oh, there it is. Now it's added it. Look. There. Lovely. Lovely. There it is. There's our horrificate. Great. Let me just... I'll bring it up in a bit, because we're going to get Claude building this now. Document is now saved. Okay, good. Let's do this. Let's do a model and change the sonnet, and let's do a compress or a compact. And then we're going to get building. And then it's time for a quick break. I want to go say hello to my kids. They're at home now. I already told them to be quiet. And they were like, sorry, Dad. And I was like, oh, I'm sorry. I didn't mean sorry. Now I feel bad. I should go and give them a big kiss. And hug. I'm sorry. Claude made me do it. That's something my dad would always do. Well, he does always, still does it. He said it's Charlie's fault. And who's Charlie, Dad? Who's Charlie? Oh, Charlie. Oh, Charlie's my alter ego. It's Charlie. And I remember as a child, I'd sit there and watch him in the bathroom. And he'd be like blaming Charlie in the mirror. Charlie's all your fault. Charlie. I'm like, who are you talking to? He's talking to himself. A bit like I'm doing right now. Oh, God. Becoming my father. Although I think I'm better looking than him. But I don't say so myself. What am I waiting for? Oh, compacting. That's it. Always waiting. Come on. Come on. 4.5, 4.6. Let's see if it's, there we go. Okay, great. Okay. Now we're going to get Sonnet 4.5 actually implementing the plan so far. Okay, Claude. Right, let's build. What else do I want to say? How do I want you to build, Claude? We haven't got a Claude MD dot yet. No, so this is all fresh. Okay. Let's do this. See if we've got the agents in there. Okay, we do have our performance code reviewer agent in here. You know what? I'm gonna just bring over Claude so you can see it. We don't need to look at that anymore. We're just looking at this. So, yeah, we got that. All right, let's come out of here. We got a performance code reviewer. All right, so we use that agent. But we've got to be very specific with how to build now, because I don't have anything set up. We have previous context on rules, so let's just do it as is. Okay, Claude, we're going to build now. Use the horrificate.md as your build guide. Please be pragmatic with your code. Be memory efficient. Hang on, let's go back. It's not be memory efficient. It's memory efficiency is paramount here, and speed is also as equally paramount. We can't say paramount twice, can we? That's stupid. No, because you can't have a paramount twice. It is the paramount. All right. Memory efficiency and speed are paramount here. Great. Implement dry practices with everything. What else? Don't be verbose with comments. Keep them to where it's only critical. And if you do use a comment, please make it all lowercase. I hate mixed case comments. I find them easier to read when they're lowercase. What else do we want? Be pragmatic about our code. We're going to use dry testing. Let's talk about testing. So with everything you build, I want full test coverage. 100% coverage isn't important right now. We will need to get there later, but I want to see at least 75% of this code covered for the first iteration, so we can verify that the mechanics work accurately. Table tests are fine. I prefer individual unit tests rather than massive blocks of table tests, but where it makes sense, please add table tests. Benchmarking is going to be important, so please add benchmarks for the core functionality of reading in that large file and then seeking X number of entries and then loading and reading and doing that repetitively randomly. So we're going to find out just truly how well this is handling. We've got our benchmarks. We're thinking about table tests versus unit tests. What else? Yeah, test file generation. That's what we were talking about earlier. So we're going to need some test files, obviously, some test har files to validate that this is actually working. So I'm going to need you to generate a series of har files using random bodies and random requests. We're going to need to generate a few different files ranging in size. The first one being 5 megabytes. The second one being 50 megabytes. The third one being 500 megabytes. The fourth one being 5 gigabytes. I'll need you to generate these half files. They can't be downloaded from anywhere. I don't want to go and generate them myself or find something like it online. Just generate it from random data, base64 encoded random nonsense. It doesn't really matter what you fill it out with, but it has to be a real representation of a half file with, the JSON as it would be in a real half file with, actual bodies that have something in them. Okay. Blah, 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 blah. We've got half files, test types. We've got our build coverage defined. Okay. Let's go. Before we do that, let's flip the table. I always love to do this part because it changes the conversation sometimes. What follow-up questions do you have for me? Thinking. Let's see what he comes back with. All right. I'm ready to build. A few clarifying questions before I start. Implementation priority. Should I implement the LRU cache in this first iteration? No, we're going to stub that out. Right, so stub out 1, 2. Index persistence. Should the index cache? Should the cache? No. I don't think I want that. I don't think I want that at all. Do we want to cache the indexes? Do we want to basically write the indexes and serialize them to disk so we can load them up again? Like, no. 3. Test file generation. Should I create a standalone CLI tool to generate the test half files or build it as a test utility function? Whoa. So the question here is, do we want to generate the test half files using a unit test, or do we want to generate using a little CLI tool that just you can run anytime and rebuild everything? I think we want to do it as a little tool. To be honest, it's a sub tool inside the tool. In Hargen. Can we come up with a different name? Better name than Hargen? Oh, I don't know. We'll leave it for Hargen right now. We can rename it later. That's fine. Okay, 3, benchmark focus. For benchmarks, what entry count range is the most important? For example, random access to 100 entries, or sequential streaming, or both patterns. I think both patterns. String interning. This is a big one. The design mentions string interning for deduplicated repeated strings. Should I implement this implementation? Ooh. Yeah, this is the question. Do we want to put this into the core of the architecture day one, or do we want to think about adding it on later where it might get forgotten about? Yeah, it's going to get forgotten about if we don't put it in, and that's going to have memory problems down the road, because I've come back and fixed these problems later on where I am looking to make better use of exploding string use in memory. Exploding string use, and this is nothing but strings and passing them. So yeah, let's do that from the beginning. 6 secondary indices. Oh yeah, I don't think we need the secondary indices right now, just to start. Okay, I don't think we need that. Okay, all right, let's answer these questions. Answer to question 1. Just stub it out for now for the LRU cache. We don't need to implement it. And question 2 was test file generation. Yeah. Answer to question 2. Yes, let's generate a new subtool. Call it Hargen for now. What have we got for 3? Oh no, that was 3. Shivers me timbers. Index persistence. Oh, goodness gracious. No, please, no, I don't care about persisting the indexes. They don't need to be serialized. They don't need to be added to save to a file or anything like that. Just, no, none of that. And question 3 was, yeah. Answer to question 3, yes, create a subtool and call it hardgen for now. And answer question 4, benchmark focuses. Let's just say both patterns. Answer to question 4, both patterns. And then let's go down. What else we got? 5 is string interning. Yes. Answer to question 5. Yes, string interning is really important for memory management down the road. Let's build it in to begin with. It needs to be part of the core from day one. And then secondary indices. Do we need those for this right now? No. Those are upgrades that we would need if we needed to do more specific searching. We don't need to do any of that stuff right now. So let's just say answer to question 6. Skip it for now. Don't need it. Okay. All right. Go. Let's see. Are we going to go? I'm going to see if I can just set it off. Okay, there we go. It's updated the to-dos. Very nice. Thank you. Just going to build all our files. Making the directory. Except edits are on, so it's already built in. All right. Okay. With that, I'll zoom out a little so you can just see a bit more. Okay. Now I am going to go and take a short break. I'll be back. What is it? It's 5:03 p.m. my time, which means it is 2 p.m. It's 2:03 p.m. on the West Coast. I'll be back at 3. Let's do 2:15. We're back at almost 15 minutes. Oh, well, it looks like hardgen is ready. Let's see. Let's see. Generate some half files and then... Oh, we haven't written the unit test yet. Oh, no. Yeah, this is probably where we're going to get stuck for the next 20 minutes. As it goes round and round and round and round. While we're writing the unit tests, and we're generating those files. Ugh. The 5 gigabyte one going in there. Written the types test. The types test is in. Let's get rid of those to-dos. I don't care about that for right now. Ooh. Testing the 5 megabyte file. Well, we're not testing, we're writing the test. We haven't run any of these tests yet. I don't even know if any of these compiles yet. Probably not. Oh, I'm missing an import. Oh, I panicked. Oh, I realized I've made it all wrong. Oh, none of this is logical. Let me fix it. 4 hours later. It's the same thing, you know, talking about yesterday. You get stuck, and then you got to know when to pull out. Right, this design, we've obviously missed something somewhere, or it's done something stupid again. Over-engineered it, put a bunch of stuff in there, overcomplicated it, and ended up with a bunch of mess, bunch of slop, AI garbage. I'm just taking my hoodie off here. It's hot in here. Brain's still going. It's 5:20. This is normally way later than I would be coding. Oh, there we go. We do want to see CD motor and test cover. Yes, we don't want it. Ah, there it is. The first failure. Failed. The garbage you've generated is garbage. Oh, you're going for comments now? Come on. Failed. I do like watching it fail over and over because it's quite rewarding. Like watching it figure it. This is the clever part, really, is watching it. Or watching Claude in particular. I'm watching the agent just build and fail and refine and build and fail and refine and build and fail and refine. And most of the time, it does funnel it down. What we got? Go covered. Yeah, this is the coverage now. Poor, can't be that far along already. No, failed. There we go. Lovely. More failure. Oh no, that's just the command is wrong. But yeah, usually the funnel gets clean towards the end. But sometimes it can spin off into outer space. Although I find it happens less and less these days. Maybe it's my prompting's getting better. Maybe my skills are getting better. Maybe the LLMs are getting better. Maybe the tools are getting better. Maybe it's all getting better. Maybe it's a combination. What's it? Cacophony. That's the one I was thinking of. Cacophony. Right in the benchmarks, we've got 62% coverage. Whoa, it's not quite 75, is it? Not quite the 75 I asked you for. Oh, 73. Oh. Ooh. Come on. Let's take a look at some of this code that it's writing while it's doing this. Let's go flying over some code. Alright, let's get rid of that. And we have the motor. Ooh, lots of files in here. What's the index? An index builder. Parser. Using the decoder. Yeah, that's right. The standard lib token parser. Okay, this is nice. We've got our interface. Standard lib token parser. Great, and it's implementing. Where's our to read deeper into this. Interfaces that they are. Yeah, they're interfaces. Horrificate. Ooh, I think we need to change that name to Horrifify. Maybe. Over rotating on this. Entry reader. This is all good. This is all what we defined. It's all looking good. There's our cache. Benchmarks are now running. Cache looks good. Let's take a look at some of these types. Looks reasonable. It's compressed. I'm using gzip or not. Okay. We need to go and run Go format on this. That won't work. Now we're looking. Yes, I want to. Yes, do that. Yes, Claude. You don't need to ask me for that. Yes, find commands are fine. And we've got a string interning here, which is good. Adds a string to the interns a string to the string table. Yeah, this is like it's a really clean, effective way to stop strings being just duplicated all over the place. This gives you a nice, clean, single place for individual strings, just simply because strings are immutable, and you always make a copy, always copying them. Massive memory drain. Spent a lot. You can't be serious. You can't be serious, Claude. You're saying you're done? No. Excellent. I've completed the implementation of the motor module for Braid. Here's a comprehensive summary of what was built. Module structure. Completed a complete motor module with the following files. Interfaces. Let's go through this bit by bit. interfaces. Yeah, we just looked through all that. That's all good. Then we got the types. Yeah, we're just looking at that. We were just looking at this. It's good. The parser, we just had a look at that too. And it was a standard lib. Yeah, that's fine. Yeah, those are runes. Yeah, that's fine. Oh, hang on a minute. No, yeah, that's fine. Okay. Yeah, that's good. And then we've got the index. Love an index. It's one of the major sources of pain in libopenAPI. Major sources of pain is the index. It was the first thing I built, and I built some of it wrong. Because I was using it as a sketch and I didn't go back and fix it. So that's why we're not making this mistake again for our new build. We are not going to come back and fix this. We are going to get the pieces that need to be... What is that? Why are we using this? There should be constants. All right, default index builder. Let's... In default index builder, in the switch, you've got a bunch of cases with strings as keys, which is fine. Can you make them constants though? I don't know about you, but I just find this really dirty. And I do it myself. I've done it myself 100 times. Whenever I see it, I'm like, oh, I can't clean that up. Sometimes it doesn't need to be cleaned up because it hurts. There you go. Thank you. Create some consts for me. Lovely. Change that to... Oh, you're doing it all over the place. Index.go. Why haven't you changed yet? Refresh that cache there. Alright, don't know why that didn't happen. I didn't update. Anyway, this is right. It's much better. Much better. Alright, now what else were you working on? Reader. Okay. Read that. For now, we use a simple approach, repass from the beginning and skip right to this looks like crap. What the hell is this? What is this? For now, we use a simpler approach, repass from the beginning and skip to the right entry. What the fudge? Well, let's just see what it says here. Before I start nitpicking, let's see what it says. Before I get stuck in that, what is that? Reader, streamer. Yeah, simple. Get entry. Check the cache. Read the file. Stream range. Maybe we should use the new. Yeah. Some notes, because I'm starting to nitpick on this. I would like to. So what I'm thinking about here, this weight, we've got a weight group here. There's a new update in. Well, it's not new update. It's Go 1.125 that has a new weight group interface. It's basically taken the same design that Conk used to use. Conk is like a weight group simplification, which means you just fire off a function, and you don't need to worry about this here where you've got add delta 1 and work group done. You don't need to worry about this because you would just say, work group go and fire the function, and it would take care of the tracking of when it was done or not. You wouldn't need to call it on the weight group, which is what Conk does as a wraparound. And it's way more effective. It's fine. I mean, this logic's fine. It's just we could do it the new way. I'll make a note of it. Use new go. Worker pool. Spawning. That'd be a better design in my opinion. More future-proof. Easy to read. Because, I mean, it's not that it's hard, but, it's just, we could just delete a couple of lines of code here. Always like deleting lines of code. Right. And then what else was there? There was cache. I think we already looked at that. Yeah, that's just, there's nothing in there. Just a stub. All right. Oh, and it'll be hard gen tool. We generated all of our half files, which is great. The initial benchmark results on Apple M4 Max, which is what I'm running. Random access file, 9.2 milliseconds per random entry access, 3.9 memory per operation, 100 reads. Successful. Okay. Sequential streaming, 5 megabyte file, was 24.8 milliseconds to stream 10 entries. 8.5 milliseconds average read time, and 97 entries passed by the parallel workers. Okay, that's great. Test coverage 94.6%, 74.6%. Okay, not bad, man. Not bad, Claude, me old mate. Not bad. 75% fast for the first iteration. All the tests are passing. Wow. Okay. Pragmatic code with don't repeat yourself principles applied. Lowercase comments only where critical. It's good. Coverage not out. Oh no, I don't need that. I can't read that. Dare I say it, this looks pretty good. I mean, it looks pretty good. I haven't done a full code review on it, but from what I've read so far, it looks pretty solid. I'm going to commit some code here in a minute, and I want to rerun these tests myself, see for myself. Code quality is good. It's interface driven, ready for the Sonic upgrade later. It's memory efficient, nice. Two-phase processing, which is good. We do the index and then we do the lookup. Lazy loading. 30 times faster than SHA-256. Very nice. Concurrent streaming with our worker pool. Looking good. No memory limits. No GC hacking. Definitely not. Benchmark test suite. Random access across different file sizes. Sequential streaming with configurable chunk sizes. Very nice. The implementation is ready for use. Let's see, shall we? Let's see. Go test bench mem. Let's do that. Let's see what it says. I'll move over to the terminal for the time being. I mean, editor, sorry, not terminal. So we can just see this a bit better. go test bench. Do it in the local directory, and we'll bench the memory. Bench mem. Where are we? And then we need to go into motor. We're running. We're running. 500 meg. Did we not do a 5 gig? Did we not do 5 gig? 5, oh we did. Where's the 5 gig? Man, this is working. Well, not on the 5 gig though, we don't have that tested. Maybe that's for tomorrow. It's getting late. Index build, sequential stream. Benchmark format. That's fast. So fast. Some things are slow though. Some of them too fast. All the interning, yeah. Okay. Well, I mean, it's good for now. We test the passing. I'm just going to run them here. $50 tests. They all pass. All of them. It says we're ready for down here. We go down to Claude. It says we're ready. I think what I'm going to do is I am going to take its word for it, to be honest. Tell you what, let's just move this down so we can take another quick look through this and make any other notes on anything else that seems obvious. Let's go back to the top. Oh, cache. There's nothing in there. There's nothing in there. In the index, this is what we're looking already. We're using the right RFC for the timestamp. That's all good. You know what? Let's do one more thing before we commit this code and call it a day. And move on, and tomorrow we're going to review all this code one more time, and then we're going to move on to the next part, which is actually using this and building a command console around it. But for now, what I want to do is I'm going to bring up the terminal again, bring up Claude again. All right, we're back here. Let's did you run the performance-code-reviewer against all of this? Reviewer agent. I'm not sure if I saw it. I think I saw it running. I'm not sure. And if it's already run it. No, I didn't. Keep. So you can never trust Claude to make sure it's run that damn agent. Even if you put it in the Claude.md, you put it, all the configurations like, oh no, sorry, I forgot. Sorry, I forgot again. And that's what you got to do. You got to tell it. Pull your act together, mate. Get all your stuff. Gather it all up. All your stuff. Gather it up into a pile. Just gather it all up. Get your stuff together. Gather it up, Claude. It's all over the place. I would use an expletive. I don't want to get in trouble from the internet, please. I usually use a lot of expletives, but you never know who's going to get upset. So it's just easier not to use expletives. It's very hard for me though. I can't stop myself most of the time, so it takes a lot of mental energy. A lot of mental energy to not just say, for fresh sake, Claude. Fudging hell. Clucking bell. That's a good one. I should say that instead. Cluck me. What's a clucking bell? Clucking bell. Yeah. Yeah, we use some of the old Cockney rhyming slang. Still waiting. We're still waiting for Claude. In the meantime, you know what? While we're still waiting, we'll go back to having a look at some of that code. Yeah, we were taking a look at that go routine mechanism. It's all clean. I mean, the code is clean. It's clean code. It's well written. There's no fluff in here. There's no bump. There's no over engineering. It's pretty solid. I'd be impressed if someone. Oh, what's that? No, that's fine. I'd be pretty impressed if somebody put this in front of me. In fact, I'd be really impressed to say, "Wow, you're a good engineer. You're worth your money." Or 1,300 of it. $1,376. Actually, it's probably more than that now. Probably more. Oh, okay, great. What have we got? The performance code reviewer agent found several critical issues. Of course you did. Yeah, this is exactly what I was saying. Like, what is this nonsense? Exactly what I said. The readout. I made that note. A readout. Well, what are you on about? Let's go and have a look at that. The readout. Where are you? Readout. Right, there you are. I'm trying to find it. Readout. Oh, it tells me that's the wrong thing. I'm doing the wrong thing. I'm doing the wrong thing. Read that. There you are. Read that. What's going on here? Something's been deleted. That was me. That was me doing that. I messed that up. I don't know what I was doing. I don't know what I was doing there. But, yeah. Right, this is the problem. This is exactly what I saw a minute ago. I was going to let it slide for a minute because I'm like, okay, we'll fix that tomorrow. But clearly not, because it's bloody wrong. It's bloody wrong, Claude. Of course it's wrong. For now, use a simple, what do you repass from the beginning? It's like the whole point is it's useless at scale. Number 2, file handle leakage, every readout. Yeah, I know, it's rubbish. Broke it. File offset. Okay. I didn't see that one. I said that specifically, you swine. Ugh. Alright. Excessive and another one. And explicitly said to watch that. And race conditions. Yeah, I know. Yeah. Alright. I want you to fix all of it. Fix all of it. Every bit of it. We'll just fix the critical for now. What do you mean critical? Like, it's like we're doing like, no, now. It's brand new. It's brand new. How can it can't come in to the product crap. It can't come in half cooked. It can't come in for now, we'll just skip all the logic and just return 1 and write a test around that and say we're done. I mean, that's basically what a lot of engineers think, quality code is. Like, well, we'll just skip all this, disable all these tests, and then we'll just do this. Take a piece of wire and we'll short circuit all the logic and we'll just put this lovely big loop, skip over the logic and bypass all of it and mess up the system in all testable ways. Not sure what the word is I'm looking for that, but I mean, I'm trying not to swear, to be honest. And it's hard. It's really hard. It's really hard. Harder than I thought. For doing it for hours on end, that is. I can only do it in short bursts, but hours and hours and hours and hours on end. It's challenging. Very challenging. Are you fixing all the broken Claude? Oh, look at that. Oh, this is where we start to get into a mess. Let me fix this. Oh, I broke that. Let me fix that. Oh no, I've totally broken that. There we go. We fixed it. We fixed it. Thank you, Claude. That's better. That's better. We'll let it fix. We'll run the tests. And then we're going to commit the code. And then we're going to call it a day. I think that's pretty good progress, to be honest. Minus some of the silly things that the Claude has done out of the gate. And some of the backwards and forwards we had to do to get the right thing out of the LLM. We've reached a good place. What I'm going to do, or try and do tomorrow, is try and get Codex to do a code review of everything and see what it comes back with. I might actually come back and do that. Yeah, we'll do that tomorrow, not today. So I'll push all this into a branch and then I'll have Codex put it down in the morning and then we'll go through a code review of Codex. And then we'll backwards and forwards on that for a minute. And then we'll move on to the next part. The actual application and not the engine. Getting rid of all of that crap. Thank you. Useless. Motor. No. You've got your file system messed up there. No directory motor. Oh no. Exit code 1. Come on. Fix it. Oh dear. Come on. String table. We doing? Oh no. Not break. How much have we broken? How much are you breaking? Don't break on me, Claude. It used to surprises me actually when it starts doing this stuff. It all looks very broken, and when it comes back, it actually does work pretty well. Still needs polishing normally, but now we've messed it up. Oh no, it's just a test. Okay, that's fine. This is fine. Index. Why are you deleting tests? Why did you do that? Deleted index helpers test. How's that going to affect coverage, mate? Probably balls it up, haven't we? Now we're deleting methods. We've deleted the string table. removing all references to it. I'm not sure why. Not entirely sure what that string table was. Hoping it wasn't important. I hope it wasn't important, Claude. Good to see you, Dreams API. Thank you for watching all day long. You've been on here for hours. Good luck with the rest of your evening. Have fun. We're not too far away from the end here anyway, to be honest. Once this is rolling, we're going to call it a day. The stream will be earlier tomorrow. We'll be starting earlier. We started late today because I wanted to wait because we had a kick-off meeting. So I'll be starting the stream earlier for other people who are in different time zones. We're almost there. Almost there. Not far off. File content byte. Why is that in there? Why was that not in there before? Do we want to put the file content in the index? What are you doing? What are you doing? Deleting more stuff? What are you doing, Claude? What are you doing? 61% coverage. What is this? Test offset. Why is that in temp? Oh, wait, he's going to delete it. Okay. Oops, I'm in the wrong window here. Wrong window. Oh, yes, load file system differences. This is also the part that gets old, and it's something that doesn't tend to happen with Opus. Is this slow grudging grind through fixing tests that is trying to run stuff from /temp and it's putting things all over the place, and then the working directory gets messed up and it tries to run things that aren't there and it doesn't know where it is and it gets confused and you got to wait for it to find its location, then it's got to go over here and go over there, and it's like 20 minutes of like, now you've gotten back to the directory, your working directory you're in, and now somebody can't run the commands or the agents won't run, and he's like, ugh. That hasn't been worked out yet. Those kinks are all very they're all still very prevalent. But like right now, it's updating the tests, fix the new implementation, the performance code review agent, found a bunch of mess, of course. Exactly the same stuff I was pointing out. I was like, what is this nonsense? This isn't going to work. And we have re-implemented those pieces, hopefully using more performant code and actual implementations of the real code, not the nonsense we put in there. So here's all these grand designs, you know. And this is actually something that I saw really prevalently with Gemini when I was working with Gemini before I threw it in the trash where it belongs. Maybe not. I haven't used it in a while. Maybe it's any better. But I was using it, and it would just, like, it would build it all out, like it would stub it all out. But just that's it, just stub it all out. It says it's done with a comment, you know, to be completed later. And you say, well, can you fill it in? And it says, and I put another comment in, yeah, will be filled in. Like, what? I wouldn't necessarily do that, but you know what I mean. It would. Maybe you don't know what I mean, but it would always build something that didn't work. It's just like the Occam's razor to completion. It's like 1, 2, miss a few, 99, 100, done. It's like, no, you're not done. You've missed all of it. No, I went started at 1, ended at 100. Yeah, but you missed 96%, 96 of the numbers. Just trying to get these tests up and rolling here. And then we will run them. And then we will commit the code. And then it is time for burgers. Burger time. Everyone loves burger. 11 minutes. 12 minutes so far. 12 minutes. 72%. Ooh, Claude. 75 is a goal. You can listen to that. Remember that. Yeah. Running the full test suite and the benchmarks. Great. Go to cover. Let's do it. Come on, mate. Come on. 75%. High quality code. 5,000 tokens. 6,000 tokens. 7,000 tokens. Ooh. Tomorrow, hopefully, we can double agent this, and we can get Claude working twice. Or triple agent. We're going to do triple agent with codex and 2 Claudes. 2 Claudes and a codex. I'll have 2 Claudes and a codex, please. Does kind of sound like drugs. All right. 72%. I'll let you through. 0 allocations. What? Production ready? Yeah. No, you're not. Far from it. But let's have a look. What else we got in here? Implemented the actual byte offset tracking. Good. Entries are now still real buy positions. Good. Oh yeah, lovely. Lovely. Performance gains 38% faster. What? Really? File remove, yeah. Removed reopening on every read. Yeah. Memory gain 13 times less per operation, 3.9 megabytes to 3.01k. Oh, that's what that was going. That's why I deleted all that stuff. Remove the broken. Yeah, okay. I didn't see that. I didn't see that either. That would have come out in the wash. The channel buffer sizing. I didn't see that. I missed that. Performance improvements. Oh, that's why we removed all of that string table stuff, because we've re-optimized the interning. Okay. All those drive violations. Good God, yeah. 80% of the comments. Nice. All right, let's run it. "48 tests passed." Come off it. How fast did that run? Cheapers. No. Come on, man. That can't be right. Not running the benchmarks. Yeah, let's run the benchmarks. Wow. Let's do that again. Let's run those benchmarks here. So we're running them. Actually, I shouldn't run them. Double run them, should I? That's way faster. Look at that. Look at this. Look at this compared to... Oh no, it's actually slower. Oh no, it's faster. That's the number of iterations it runs. Look. Yeah. Look at that. I was wrong, yeah. It's way faster. Damn. Yeah. Wow, that's way better. Nice. Okay. Wow. Look at this. Look at this. Beautiful. Beautiful. It's beautiful, but we still don't have the 5 gig in there. Doesn't matter. We'll do that tomorrow. Okay. Very exciting. Very exciting. I'm actually pretty happy with this. I think it's a good day. It's a good day. It's a good day. Let's come over to... I want to change to my Git tool. This is straight over to Tower. I use a tool called Tower. I've been using it for years. I love it. Tower is great. I can't zoom for some reason. So I'm going to zoom. Can I zoom? Window. View. Zoom. Oh, no. No. That's not it. That's not what I wanted. That has messed it all up. That's messed up everything. It's made it full screen. That's not what I wanted. It's going to mess up the stream. So let's fix that. There we go. And we'll try again. View. I can't zoom in. You know what? This is just going to have to do. So we have our files. We've got a command, our go mod, go sum. So this is our hard gen main. This is just going to commit it for now. We're in main. Yeah, we might as well, because we just run main. There's no point branching it. We haven't got anything in it. Go.mod. We got xhash and haha. That's all we need. We got a go work file. We can't commit that. We got a binary. We can't commit that. We got that. Yeah. Yeah, I'm going to keep that for the horrificate because it's our build plan. It's part of the project. Keep it for now. Motor. That's all of our code. Don't need that. Don't need the coverage. And horrificate. Yeah, that's what it is. So bench test. All the tests. Our readme. And the test data. Oh, no, we don't need test data. sugar. I shouldn't have clicked on that. He's trying to read all the files. Ah, that was a mistake. You see? Made a mistake now. It's frozen the damn thing because it's trying to look in there. I don't want that. I don't know what it's doing now. No little modifications in this directory. I'm going to exclude this item. README, there's nothing in there right now. Changes will be made, it's just white space changes. All right, let's commit this. Let's go say day one. What was it? What's it when it's what do I call it? What do I call this? I call it let's just call it day one braid hackathon. Today we built the core engine, the horrific engine. Horrific, man. I love that name. I'm just thinking about it. I might change the whole thing to called horrific. I need to think on this. Maybe not. Braid is a better name, but horrific. I love it. I love it. Okay. We have the parser and most of the base mechanics implemented. Tomorrow, a review and a tune, and on to the next part. I know that doesn't make much sense, but it's the first real commit and there's nothing really in there, so it's just a bunch of code. Look at that, look at that, you knew it. Get rid of you, get rid of you, get rid of you, get rid of you. It's just frozen now. All right. Yeah, I knew it. I'm trying to read in a 5 gig file so we can render it out in here. It's like, stop. All right. They handled it well, just a bit slow. Tomorrow, review and tune the next part. Yeah, the engine. Stream a half file. I'm just going to type, I'm going to talk complete. Actually, it maybe didn't work. Complete with an index, a pluggable cache, and what else? All right, that's fine. That's fine. That's fine for the day. Okay, let's commit. We're gonna remain. Should we stay in main? The bomb. There it is. Look, the bomb. If you ever play the game, you'll know what the bomb is. Oh, I'm done. That's good. Let's go. I'm going to push the code up to main. All right. Thank you for sticking around. I don't know who's watching. I don't know if anyone's watching. Or if you're watching the stream, the replay, thank you for sticking around. It's been a long day. It's been a fun day. We've built a lot today. We did a lot. We effectively defined the entire core of the engine. It seems to be working well with the tests. Haven't done a deep dive on the code yet. We're going to do that tomorrow with Codex and take a look at it and make sure everything looks great. And then we're going to move on. Until then, I'll see you next time. You will in a second. See me next time.